Good morning, everyone. I hope you're all good. Let me just share my live stream with everyone. Yeah, so no gym today because the gym is... Yeah, it's awkward to get to the gym today. So we're just going to go earlier. We're just going to do more coding. We're just going to do more revision. We're just going to go harder. We're just going to get more stuff done. So, let me just get up the chat. I've also told off the bot. The bot will no longer harass you for chatting. And there's a couple of things that we're going to do today. We're going to, as usual, do the revision first. This is stream bait. Here we go, yeah. Good to see you, Jackie Jen. Fall for it every time. Exactly. Alright, so 3 things that we're going to do today. We are going to do revision studying as usual, but this time we're going to fix this kind of code, right? So at the moment we have a lot of code here that is just thrown into master, right? So this is hard to read for anyone who's like going to look at my project on GitHub, which is linked below, by the way, if anyone wants to know. But the fact that this is just int main, everything's just in int main, it's fine up to a point, but I think it's starting to trip me up. And that's the most important thing, honestly. If I have like entities that I want to delete and stuff like that, it's getting a little bit tricky to handle them if everything's just in main. So yeah, this is going to be a debugging stream. This is going to be a refactoring stream, probably. I'd probably more accurately describe it. We're going to move stuff around. We're going to continue on what we were doing yesterday. Just so people who weren't here for the last part of the stream yesterday. What we did is we managed to connect our entity system to Jolt. So if I fly us into a rock, we'll get sound effects playing. Obviously, this is just to demo stuff. So that means we can update the... So that the player is making a noise when that happens. And this will allow us to do more stuff in the future when we collide with other things. So yeah, that's what we did. We also clean up, like, we move the duck into the... more into the sphere so it collides better. So yeah, that's generally what we did yesterday. It was a big task because we had to connect a lot of different things. I had 2 different architectural ideas that weren't right, and we finally went with a 3rd architectural idea, which was actually going to be useful for what we need. And then we can actually build stable IDs for our entities after we've refactored everything. So those are the 2 things that we're going to be doing today. We're going to add we're going to slowly be adding more and more stuff as time goes on. So yeah, we're going to start with a bit of revision. I'm probably going to do less revision today, honestly, and more studying. I don't exactly know what we're going to be studying. I'm probably going to go back to graphics theory. But yeah, we're going to do a couple of hours of this, a couple of hours of that, and this should be our longest stream that we've ever done, assuming that the internet doesn't go down like it did yesterday, which is why there's 2 videos up, if you're ever wondering. We have 2 VODs because my internet went down. Very annoying, but it is what it is, outside of our control. So yeah, without further ado, we're going to open up our Obsidian, which is our note-taking app that I've got, and we're just going to read through some random stuff. Like I said, I don't think I'm going to take that long, so let's start our timer for work. Yeah, and like I said in the live, when I posted this live stream live, it's important that I don't take it easy on myself. I'm not smart enough or talented enough to not work hard. So we're going to grind today. We're going to keep grinding. We're not going to stop. So what do I want to do? How do I want to study? There's graphics theory. There's high dynamic range. We've got all this kind of stuff which I can remove, which I'm probably going to review at the time we end up studying. We did assembly yesterday, so let's just have a look at our map. Right, so we have a bit of C++, which might be useful. with some threading ideas. What do we have here? We have performance, which is just general data-oriented design plus SIMD operating system stuff. I think because we're going to be probably messing around with more Vulkan today, we should probably stick with Vulkan and just go with the stuff that I'm not as familiar with. Oh, I also need to make sure that I make notes on in place back. Sorry, in place new. So this is just going to be a note. In place. In place. Mint new. This is something I kind of messed up yesterday. So I need to just make some notes on that. Make some... Just a very small one. I don't need to do anything fancy. Just explain my... Just so I don't forget it, because I forgot what I did yesterday, and then someone was trying to tell me what to do, and I was like, I don't know what that means. So there's a couple of things like that. Alright, so swap chain. What should we study? Let's see. I feel pretty confident we should I should probably maybe go through textures. I haven't done that in ages. Let's keep looking. What else we've got? Alright. So I'm gonna go through texturing. Yeah, we've just got to make sure that we stay sharp on this, otherwise when we actually go to delete these fellas, it won't actually be, because we need to be able to delete textures, which is going to be different from deleting entities, which is a whole thing. And then we've got to, because we've got to thread this up eventually. And then I've got to use KTH instead of what I'm using at the moment to make sure that texturing is faster. So yeah, let's hop into this again. Instead of just sitting here reading silently, I will read this out loud. So if anyone is following, you can, you don't have to read. But yeah, okay. So this will be as basic as it gets, and then I'll get more advanced. Introduction to texture mapping. Texture mapping is pretty complicated and requires a good use of memory layout transitions. The overall idea of adding a texture to some polygons is you create an image back with memory device. A memory back. I'm going to say with. Just get rid of that. File it with. So fill it with pixels from a file. Create an image sampler. Then use something like descriptors to add a sampler to our colors in the fragment shader. You can technically not use an image sampler. You can just upload the image directly if you need the raw image. Made me laugh then. Rest assured, I know how to read. That's funny, that. I believe you. Don't let me choke. But it's more for the viewing experience. If you just wanted to sit down and hypothetically, if people were watching, I would want them to be able to just as little effort as possible to enjoy the show. I call it a show because to me this is more like a radio broadcast, if that makes sense. Anyway, yes, we have already talked about this in what is an image view and how to create an image view. But we need to do more than what... I haven't read these notes in ages. What we did to handle textures, it is similar to setting up a vertex buffer, honestly. You need to make a staging buffer, then transfer over the staging pixels into the final image ready to be used. Nice. We'll also worry about memory layouts. On top of this, we have seen some of these before. So here's a quick list. Okay, so VK image presentation is optimal for presentation. Color attachment optimal is optimal for attachments for writing from a fragment shader. VK image layout transition source optimal for being the source in transfer operation. VK image layout transfer destination optimal is optimal for being the destination in transfer operations. So yep, that's pretty straightforward. Image layout shader read optimal for sampling from a shader. VK layout general can be used for anything, but it's less performant for everything. You might need to use it in a special case, like when an image is both an input and an output, or reading an image after it's been left in the pre-initialized setup. This just to add an extra bit of information here. As far as I know, NVIDIA graphics cards pretty much just put everything in VK image layout general anyway, so a lot of this stuff that you might have got, you need to be careful with when you're transitioning the image layouts to whatever, is kind of ignored. So you can end up, if you have an NVIDIA card and you're programming Vulkan, you can end up in a situation where everything kind of works even though you've got something wrong. Let's just say, I don't know, you try to do a very common one is VK layout image color optimal, and then you try to read that in a shader. But you know, that will work on an NVIDIA card because it'll just be in general anyway. So yeah, it's something to be aware of. Anyway, when handling textures and images that come from that, you'll need to also use pipeline barriers explained in this. Okay. Yeah, you should explicitly transition the image to the correct layout and not assume general. Oh, without a doubt, yeah. Thank you for turning up, JTAG. It's good to see you, dude. Yeah, it's not like a good idea to just assume that general exists. That's the 100%. Thank you for bringing it up. The reason I brought that up is that I said that general is used on video cards is that you might get errors if you do something wrong when you transition, and it will still work on NVIDIA cards, and you'll get validation errors, right? But just because it works on your computer doesn't mean it's going to work on other people's computers effectively, right? That's what I was bringing it up for. But yeah, thank you, JTAG, for clarifying that. Yes, transition your images properly. Do not do not assume that they're always in general. All right. Okay. So loading. Okay. So this is pretty straightforward. Loading an image file. I think I made this quite brief anyway. I'll be using the Fantastic library for images and STB images. So include that in your project. Okay. So this is not the meta anymore. This was the meta back in 2016. But there's a KTX library that you should use instead, really, and that is in the How to Vulkan tutorial. My engine doesn't yet have this in, so this is something I need to kind of write a note about and figure out how to do. But anyway, yeah, you need to write the implementation in. Yes, that's why explicit modes are better, because those guarantees. Yes, 100% yes. Yeah, JTAG's 100% right there. Yeah. Be explicit in explicit modes and all that kind of stuff. So I'll be brief because I've done this before. This is just loading files from. This is not complicated. This is almost nothing to do with Vulkan. This is how you load an image with SDBI image. I think this is still used for high dynamic range textures, as far as I know. I don't think KTX actually handles images that use the HDR image format for equirectangular images. I don't think you can load it with SDB image though, I believe. I could be completely wrong with that. I actually don't know. So it's not like this is completely useless. That's what I'm saying. HDRI, you mean... Yes, for skyboxes, yes. 100%, yes, that's what I mean. Unless you know JTAG off the top of your head, if KTX users can handle those file formats. I actually don't know. Anyway, so I'll continue to read this though. What we have here is the image size of what we have here are the total memory size of the image with the device size and raw pixels. VK device image size, image storage buffer, VK. Okay, so this is like this is more like, again, I would use VMA instead of trying to upload the image yourself, but effectively you need to transition the image from this is setting up the staging buffer. So you would have you'd be source transition source, and it would be if you were doing it without VMA, you would have to make it host visible and host coherent, and you'd have to use this, but you have to be aware that VMA does a lot of extra allocation stuff for you. VMA is the Vulkan memory allocator, which is a common library that everyone uses. So some of this stuff will be a bit dated, but yeah, this is still used to this day, where we actually do like a basically mem copy once everything's opened up for our staging buffer, and then we transition that out. Once we've done that, we don't have to have the pixels anymore. Yeah, HDRI, is that what it's called? I thought I meant the file extension .hdr, but yeah, probably HDRI is probably correct. The actual file, it's like calling, yeah, the file. I was kind of naming the file after the file extension rather than the actual name itself. You no longer need to staging buffer, by the way. Check VK host image copy. I saw this. It's not. Last time I heard in 2025 or 6. I heard a talk about this. Sasha gave a talk about that particular extension. It's not supported everywhere as far as I know. This extension, I don't think it's called yet in Vulkan. Is that correct, by the way, or am I just... it allows you to upload an image data without having them to be host visible. Yeah. Thank you for explaining the context, because I heard this extensions before. I didn't know what it was. I heard that it's not supported everywhere. And now I know what it's about, so that's actually really good. So what I'm going to do is... I'm going to make a quick note of what you've just told me, and we'll probably throw that into my notes in general. So in the I don't know what I'm going to type in here. So no, I'll make. I've got a rough notes section here for this reason. Where should I put this? Yeah, I'll just make a new one. Stream stuff. So yeah, just so I don't forget it, I'm going to write it down now, what you've just said. Let me just... So I'm just going to type it out, if that's okay. Because this is something that's going to be useful in the future, I feel like if I take a long time to make my game or whatever, I might end up just kind of transitioning this over. Is an extension that allows you to upload images without them being visible. Okay, very nice. I believe I'll look this up. This will be something that we turn into a node later on when we do a bit of studying. Along with placement new, I need to kind of make this here instead. Just something I kind of messed up yesterday, so I'm kind of wanting to fix that knowledge gap. I believe it's not yet super widely supported, but it's worth looking up on the what is it called? There's a website, I've got it bookmarked on the Vulkan website that checks how well supported an extension is, which I will look at later. What have you said as well? I just know that the big drive in modern Vulkan for the 2026 roadmap is to have better access to memory. Nice. Right, so this is tied in with the 2026 roadmap with Vulkan, to have a to have if I've made like a botched sentence, I'll come back and fix this. This is just kind of get it on there so I can expand this later. Better access to memory, which is cool. Nice. The end goal. Okay, so I'm just going to type this out, right? The end goal is to have the entire GPU VRAM to have no limits, no size limits, and be completely host visible. Nice. That's actually really nice if they actually do that. This is supported completely if your motherboard, I might even make this motherboard has a rebar, which I'll probably make a note on as well, because I don't think I did that. And yes, you are correct. Extensions mean you don't need host visible images, and you don't need staging buffers. You can go direct to Vulkan functions. Nice. This all means you don't need staging buffers and can go straight to upload the data directly. Hell yeah, dude. It already works out, but most motherboards don't support rebar. It already works out, but most motherboards don't have rebar support if they are too old. Yeah. So I'll make a note here to dive into rebar. So what we'll do, I think we've got something to study later on then, and look into how supported this is. Fantastic. Okay, thank you for that. Actually, that's going to be really nice to research later and make this into a big set of notes that I can refer to later. And I might even do start looking at KTH, because I actually need to look at this at some point. KTH, start to look into KTH. Even if I don't implement it today, I think it's going to be useful to start figuring out how this works, so you can handle textures better. I don't exactly know 100% what it does better than. I think it just handles compressed textures. I don't know. It's one of these things I know exists and I should use, but I don't exactly know why. But we'll come back to that. This is going to be part 2 of the stream, where we kind of dive into these 3 things. So I'm just going to kind of make a list. 1, 2. This whole thing should be 2. I'll do it like this. This is a rough note, so it doesn't really matter if it's a bit scuffed. 3. Fantastic. Okay, cool. Thank you for bringing all this up, by the way. I've never used KTH myself. I normally convert external formats to my own simple image format. For consistency, every texture in my engine uses the same format, etc. Wow, okay. Convert... What's your custom format, if you don't mind me asking? JTAG. Is it some kind of like compressed block format or something like that? Because that's really cool. While you answer, I will begin. I'll go back to our reading. And I will edit my notes briefly on the things that we've just done to say that in the future... Okay, so the theory of these notes, by the way, just if anyone wants to copy what I'm doing when it comes to these like little bite-sized notes, these should never be set in stone. They should be kind of editable. Oh, wrong one. So now in 2026 things are moving away from using staging buffers. Vulkan has begun work on making the whole GPU be able to access all of... No, all the way around, sorry. Vulkan has begun work on making the CPU be able to access... I should say host. All GPU memory for uploading stuff. Right, that's just a very brief note that I will come back to. So it's just RGB 16 float with a simple header for metadata. Then I don't have to parse different formats. All my images are packed to have the same color channels in that way. 16, interesting. So, wow. That's a really cool format. So I assume with like HDRI images, you convert them down from 32 RGBA 32F to 16, and do you scale them up then? For like a JPEG, let's just say I gave you a JPEG, would you add more data in or something, or is that just kind of already have that data? Sorry, I hope you don't mind me asking. It's super curious about this cool file format thing that you've got going on. I love learning new things like this. Okay, so yeah, some of this will be outdated then, relative to this extension, but I'm still going to go through it. So creating a VK image for texture mapping, we need to convert the staging buffer to an image. You can use the buffer raw, but it's slow. I see. If you add, again, this is all caveats based on older versions of Vulkan. If you add the pixel data to the image, the pixels are called texels, which is a pixel with coordinates. Okay, makes sense. So let's get started. VK image, texture, VK device, VK creates image. Yeah, okay, very straightforward. Okay, so you need to tell Vulkan what's the so you need to tell Vulkan first what image type you need to address. Type 1, 2, and 3. Type 1 is for storing data, or gradients, texture, and a voxel. The dot extends specifies the dimension, meaning that will be different depending on the image type. 2D textures, with 2D textures, we importantly need depth 1 in the Z value, in the space for our images, height and width X, yes. Now Vulkan knows how to map each pixel into textile data. Oh, my tea's going cold. Okay. So we will be skipping MIP levels, okay. The format is important to match the same as the data, I see. Yep. So it's got to match what you've loaded. Makes sense. Tiling. No, for HDI images I use an XTR format with images in equidistant layouts. I don't use skybox images or cube maps though. I use a physically based atmosphere instead. Huh. A physically based atmosphere. So I don't need HDRI image and HDRI anymore, to be honest. Right, I don't know about physically based atmosphere. We'll have to maybe look at that too. Image tiling equals tiling optimal. So VK tiling linear. The texels are laid out in row major order. The SDBI image layout of pixel data. The VK tiling optimal. Okay, laid out in implementation defined order. Yep, sounds good. I'm kind of getting a bit, not bored, but I don't think I need to know. I think I already know all this. Maybe that's arrogant, but I'm kind of like, should I be reading this from like start to finish like a book? Just a lot of this is just like super basic. Like how does individual things work? Like, so I don't need to see like layout okay, so what I'm going to change tack. I'm not going to read everything from top to bottom. I think what I'm going to do is just pick out things that I'm kind of I couldn't explain extremely well, and then kind of read that. You can basically thank Frostbite for 50% of my engine lore. Oh, interesting. It almost sounds like you worked on Frostbite. I actually don't know. Is Frostbite open source or something? Let's have a look. Oh. Yeah, sorry. It's a jump scare you with the toe. Yeah. No, is there a Git? I should just type GitHub, shouldn't I? No, okay. Nah, look, I read a couple of their papers. Great GDC talks from the frame graphs and nice research papers on physically based atmospheres. Ah, okay, right. I will have to thank them if I ever see them in real life. No, I was kind of curious. I was like, wait, what? You somehow found their source code or something? I was like, yeah, EA do have an open source-ish standard templates thing that you can use, but I don't use that. Yeah, I was when I was figuring out what I wanted to use for my standard template libraries, I was kind of like, should I use the EA one? But I thought it would be better just to like roll my own for more educational purposes, to be honest. I've kind of realized like how limited my standard templates are at the moment. But it's fine, it's fine. Anyway, so why would we need source and destination? Source, destination. This is because just like buffers, here we need to be able to receive, transfer data. Okay, yeah. So if we're copying data into this image, we need to make it source destination with staging buffers. Again, if you're using an extension that kind of supersedes that, then you don't need this. Yeah, I'll have to look at all these things. Okay, so share mode, exclusive. Yeah, I'm not going to try and transfer it. That's for sampling. What would the flags be? 1-bit rasterization. The flag is used to sparse textures. Okay. This can be used for voxel textures. For example, if your 3D textures have a lot of expensive to allocate. So the sparse data can skip a lot of the air parts of the texture. Then we create the texture. You should really check if this is old. You can tell this is old, right? VK, RG, yeah, R8, etc. is supported, but it's so commonly supported that it's not really worth checking, and you'd have to do a lot of conversions anyway if you use a different file form, if you use different formats. The use of the image dictates how it can be bound. Oh yeah, okay. You don't have the sample bit set. You get an error, and try to when you try to sample it from the shader. Yeah, okay, that makes sense. I could throw that in there. You need to at least set the value. Set the sample. How was I doing this at the time? Dots, samples, otherwise you'll get an error if you try to sample over a texture in the fragment shader. Alright, so let's just make a space there so I can actually read that in the future. Oh, I call it stamples. Yes, you have to set the stamples value. A transfer bit means that the image can be copied from one resource to another, which is transfer source. Thank you. Yeah, my when I ask myself these type of questions, I'm like, can I explain this to other people as well, like you just did there? I want to be able to get to that point where I can simply, very simply explain this. And some of the basic stuff sometimes I'm a bit shaky on, so that's why I thought I would review textures today. So yes, thank you for explaining that as well. It's always good. Always good to go over the basics, isn't it? Anyway, so create an image. Yes, we don't need to worry about the format anymore, really. I'd be surprised if a graphics card does not support RGBA. It only supports BGA, BGRA, or whatever it is. Okay, so this is what you would do without VMA and without an allocator to work around. You then set the memory exactly the same way with allocation buffer, but the only difference is I've extracted out the memory type into its own function. So this does a lot of work here to figure out what is the appropriate memory type flag, which again, this looks like it's going to be completely redundant in the future, because this has to do a lot of work to figure out exactly what, a lot of finicky stuff to figure out the memory types that are available and the memory types that are appropriate. So it's not always the case that the memory type that you want is available, so you have to make sure that you get the right one. But again, I use VMA now, so I don't really have to touch this particular struct. Oh, so allocations will be the same in the future. Yeah. Same as other things, yeah. You still have to allocate memory for resources. Yes. This is more complicated because there's a lot of there's a difference between device local and host visible, but it sounds like with this image upload thing that effectively in the future we're going to end up combining these two together, assuming that you have rebar. Yeah, stick to VMA honestly for the two places I use it. Yeah, it's the same here. I don't use it that much. I'm trying to be what air quotes correct here with my explanation. I don't want to say things that are completely off base, because this is kind of older. This is like an older note that I wrote ages ago. Yeah, I wrote this from a tutorial from flipping ages ago, so this is before I even made my last two videos. Well, no, the entire image upload thing and rebar is about memory visibility. Is that memory is... It's not... Is that memory mappable? Memory visibility. And that is that memory mappable to the CPU or not? That memory won't be, I don't think, the way that's been uploaded. The one we just looked at earlier. Alright, so let's preparing an image is the next note apparently. I'm going to show the complete... Okay, so here we go. Texture image function to demonstrate. I don't really use this exactly anymore, but it's probably good to go through it anyway. What you need to... what needs to happen from the beginning to the end. I've written notes in the comment section. Okay, so you can probably pick apart a couple of things here. So we have an unsigned char. We also have device size. Again, Ratchet has pointed out that if you just kind of hard code your values like this, you're kind of stuck to one file format type, which may be appropriate if you've done something what JTAG's done. But if you're handling different file formats, you've got to be careful that this is actually, yeah, this magic number 4 may not be true for what you're actually trying to do here. You can request that you have alpha for sure, but this, you've got to be careful basically, effectively, if you have like more than just, you know, I don't know what the file formats would be, the sizes would be for the different file formats, but yeah, just be aware that you can't, you have to be aware, I've been told anyway, you have to be aware that the image size might be different depending on what image you have. Is it? Okay. Maybe I'm wrong there. That's fair enough. So maybe I'm completely wrong, but what was it? Let me look at my code. It was something to do with this was a while ago now. I want to say a while ago, like a month ago. So it wasn't like super long time ago. So when yeah, okay, so this is what I was talking about, really. So when I'm doing a skybox, for example, the image size is always, yeah, this, but the actual buffer that I'm actually uploading is different, because there's 6 images in a skybox, rather than 4, so there's kind of a bit, you have to be a bit careful here if you just assume that if you're uploading like one image, that it's this versus, you know, a skybox which is a 6 version, then you have to do a bit more work to figure out which one's which. Yes, the SDB code basically reads pixel height and width from the channel image, and you are telling the SDB image you want to pack all textures in 4 channels for you by yes. So yeah, if you have a, yeah, like I said, if you have a a skybox texture, then you have to do something slightly different. And yeah, this is again, this is sorry to go on about this. This is assuming that the skybox texture is 6 individual textures. If you have an equirectangular image, this will be different again because that'll be 1 image. So it's a whole like, yeah, just be aware that what type of image you're trying to upload. So for this particular case, maybe this is a unique case, but yeah, this 6 images thing is different than 1 image. Yeah, so equirectangle, I believe, yeah, it sounds about right. Equirectangle would be the same size as height width channel. But in my case where I have 6 images, then it's 6 times that. So yeah, it's a whole. Yeah, just be aware that I've messed up in the past on a particular specific image size, and it's possible that I'm gonna rip this out anyway. So because I have low dynamic range textures, which for our skybox, which is probably not very good for image-based lighting, which it isn't very good for image-based lighting, because image-based lighting requires is an input to physically based rendering. And all inputs need to be both linear and they need to be in high dynamic range. You can't put a low dynamic range input and expect the colors to come out correctly as an input, because in physically based rendering, all the properties are based on reality, and if you have low dynamic range, the intensity the relative intensity between light sources and different materials or whatever are important. So that's why we have like high dynamic range, which stores more data. So we have this like relative intensity based on different properties. Right now I have 6 images that are a low dynamic range, so image-based lighting is going to be trickier to get right with that. I am wondering if I can set up a diffuse, what is it called? Irradiance map, and just kind of upload that with the low dynamic range textures to be able to do the diffuse part of the physically based rendering calculation. But it looks like the way you're supposed to do it is the equirectangular image type, rather than, you know, uploading 6 images and then another 6 images which have the diffuse irradiance stuff kind of baked into them. Because yeah, it's a whole like things. Yeah. Oh, is it? Oh, okay. Equirectangle. I've never uploaded them. Equirectangle images are normally converted to 6 images. Interesting. That's good to know. Yes, for image-based lighting, you need HDR values, but you can replace the image-based lighting with physically based atmosphere. Okay, right. Okay, so there's 2 different techniques here. I see. So that's what you've probably done, I guess. That might be something to worth looking into then, because I'm not tied to a particular technique. Sampling an equirectangular image is too intense for real time. Yeah, you do have to do some conversion. I just don't know what the conversion was when I saw it online. I am aware that you do a conversion, but I assumed that the benefit of the equirectangular images were that they kind of already have the image. They have that each pixel is 32 bits for RGBA, so 32 bits for red, blue, green, and it's not 32 bits in total, but 32 bits for each individual pixel component. And the whole benefit was that you build up a 6, or we'll assume that you do this conversion to 6 images with that data. So it looks like, from what you've just said, maybe this is wrong, but I don't have to have an equirectangular image to do this. I can just have 2D images that have high dynamic range properties to them. So image-based lighting is 2007 to answer to environment lighting. Environment lighting versus... okay, so are you talking about like just general lights, like around the scene? The reason that I want image-based lighting... yes, the normal way to do image-based lighting is to use 6 faces of a cube map for iridance cube map and another 6 for radiance cube maps. Right, okay, I thought that was... I was reading it online, I was like, why do we have to use an equirectangular image? And now I know. So the reason I want to do image-based lighting, just so you can see JTAG, is based on my scene. If I turn off the debug geometry, I'm in space, and yes, I'm lighting up the scene basically with one spotlight. So this is obviously gonna be, there's gonna be more lights than this. But I don't know if I want to at the very least kind of have everything kind of lit up based on the background as like a base layer for everything. So everything isn't so dark, and I think it's going to be helped by the fact that I'll eventually have a cube map. Sorry, a slightly brighter cube map, so you don't have these like big black areas. So my goal here is to basically light up everything slightly orange that kind of fits the atmosphere a bit, rather than just like spamming a bunch of lights all over the place. Okay, so let's have a look. No, the ambient lighting and the environment map reflectance come from the image-based lighting, but the real way to do it is to use physically based atmosphere and global illumination. I see, interesting. That's why P, BAM and Sun come in. P-BAM simulates sun and space. Oh, physically based atmosphere. Is that what P-BAM is? Let's look at this. Okay, so this is kind of interesting. Sorry, I'm completely going off my... JTAG has given me too much information. I can't ignore it. I hope people are okay with this. Okay, so... apparently... Yeah, admittedly, my graphics theory isn't the strongest. A lot of things aren't the strongest. This is why I'm having to... this is why I'm streaming so much nowadays. I'm not talented enough to be able to just work, 4 days a week, 3 hours, and just kind of assume that everything's going to work out. I'm just not that smart. So what we might end up looking at is physically based atmosphere and GI. So okay, apparently. I will believe you on this, by the way. I'm just going to kind of write this down as apparently, because I need to look this up myself and kind of figure out like talks and stuff that we're going to like pass through and papers like maybe the ones you've read too. Now, image-based lighting is an older technique by which is used by older games to, I don't know, do something that physically based atmosphere and global illumination does, right? Okay, cool. So no, so ambient light. I'm gonna read some of your stuff so I can write this down. You know, like ambient lighting and the entire environment. Okay, so image-based lighting, but the real way to do it is to use physically based atmosphere and GI. That's where physically based atmosphere M. What's the M stand for in P? So okay, so look up. I mean physically based A, which I assume M, and sun comes in as they can be used to simulate space better than IBL can. Right, okay, so physically based sky. Okay, so let's see. Okay, so a talk worth looking at / paper. I don't know if it's something. Let's just say frostbite. Frostbite has a talk called. I'm going to copy this out. Hopefully you guys don't mind. Just hopping into here. Yep. Just copy that. Thank you. Let's get back to studying. Is something worth looking at? Okay, cool. So physically based M. I assume it's AM is just atmosphere. Can replace image-based lighting and image skybox with proper physical properties, lighting, calculations for sun, environment mapping. We get the skybox colors for free, plus ambient lighting and sunlight. Whoa, that's powerful. Dude, that seems real cool. That might fix a lot of my lighting issues, actually. Alright, so... Oh, okay, physically based ambient light. Okay, so... I'm definitely going to have to see... Based at... Atmospheric. Atmospherical. Physically based rendering. The atmospheric model. Okay, so I think I'm done with revision. We're gonna move into this. And if we have time, we'll do the rest. So if I Google this, we should see. Whoops. Nope. There might be some prerequisite stuff that we're gonna have to study, but morning, Emo and Na. We're just doing a bit of studying, trying to simulate lighting better than I currently am. What have we got here? Accept or whatever. Right, okay, so yeah, we're going to try and do something like this. Well, at least what I'm looking for is more details than just... Wow, 2016 this came out? Download course notes, download notepad. Oh, okay, this is more like it. Okay, so I'm just gonna kind of scroll through this to see how what generally we need to know to be able to do this. They do have a paper on this too. Yeah, oh yeah, that one. Yeah, thank you. So what we might do, okay, so we'll get the paper, we'll get the presentation. So what I'm gonna, oh, okay, maybe not that. What I'll do, how do I do this? Yes. I might kind of give myself a quick overview by the slide, the presentation or whatever. Download presentation, download course notes, download notepad. Okay, so oh, fantastic. So this is going to have a whole section on what we need. So what I'm scrolling through here is to figure out prerequisite stuff. Because yeah, some of the stuff from this era of video games, like 2014. Oh my goodness. It's just like it was like almost peak graphics because we didn't do temporal anti-aliasing back then. Like, so nothing was smudged. It has a particular era. If I can pull off even like something close to this. So anyway, let's so what I might need to do basically is build up a bit of knowledge here before we start. Yeah, this is super exciting. Okay, so there's dang. Okay, so this is for the clouds, I believe. Right, but that's wow. I think Hitman World of Assassination looks awesome, and it's from 2016. Yeah, it's just insane law. Yeah, that's what I mean. It's like some of the graphics techniques they were pulling off back then, just super cool. I know everyone's all obsessed with ray tracing, but this is the type of stuff that I kind of want to implement. This type of kind of jeez, oh no, ozone absorption, jeez. That's crazy. Alright. Right, so what I'm interested in is this part. This is the sun illumination. Because I'm not going to be on a planet per se, so we're going to be flying around in space. So I've got to figure out exactly how to make this useful for me. All that we are doing here is an approximation of ray tracing. Actually does without these approximations, which is quite insane. Yeah, it simulates space perfectly. Damn. Yeah, because this is going to be good because I don't have a way of simulating. I want to support graphics cards that don't have RTX, really, if I can anyway, while also achieving like amazing effects. Okay, so there's a bit of like how clouds work. Sorry, I'm just scrolling so fast because I want to make sure that if and when I do this, we have some background information, if that makes sense, just to... Okay, so there's a bunch of references in here, so we could probably figure out bits and bobs based on Well, assuming it's just not the link to a game, but we can probably have a bunch of... okay, so there's a GPU gems section. Yeah, I remember that book. Okay, so I've actually bought one of these books, not GPU gems, but Zen GPU 3, because that has a bunch of stuff in it I need to know. Alright, so... So at the very least, if I'm going to do image-based lighting, right, I should be doing something probably a bit more modern than image-based lighting. I should be doing this idea at the very least. Right, okay, so the 62 pages is going to take a good chunk of time to get through and learn properly. Alright, I'm up for it. It's going to be a bit inaccessible, especially on these streams, but I'm kind of just going to say we have to learn this, so the first thing I'll do is I'll go through the... No, I'm not going to do that actually. This is just going to be less useful. Unless there's a YouTube talk that goes with it. Let's see. Let's see if it's on YouTube. Physically based rendering and... Is that the same deal? Is that volumetric fog? Yeah, that looks like fog. Image-based lighting. Yeah, stick with the image-based lighting for now to make some stuff. Then later you can work on better renderer for more modern techniques, like pretty much real-time everything. Yeah, there's a SIGGRAPH talk from 2016. If you're unsure if it still exists, that's also a great PDF too. Yeah, it looks so awesome. They have examples of Mars and stuff. It works based on the camera position to determine if you're inside an atmosphere of the world. Ah, okay. Which is in space. Interesting. I have created a website. I've created a website. Will you check it? Will you check? I'm 14 years old. The problem is you can't give me a link on YouTube, and I can't check it. I can't click on stuff on the live stream. That's like a website. But if you have like a GitHub or some kind of thing that I can check out off stream, then yeah, I'll check it out. The reason that if someone sends me like a website link, I've got to be very careful that it's not like some troll or something doing something silly. Hopefully you can appreciate that. Yeah. The physically based and uniform is also a great one. Fantastic. Alright. Graphics theory. What should we learn? So, JTAG said, in general, that we probably don't need to worry about it. I haven't started with image-based lighting yet, so I'm kind of tempted not to go with it and just kind of drill into physically based atmospheric stuff and kind of figuring out maybe ray tracing is the way to go. I don't know yet. So what we're going to do is we're going to figure out, I think, an approach that's appropriate and get better at the maths and stuff or whatever that's needed for all this type of stuff. So this is also a great talk apparently, so that's good. But yeah, it looks like it's not available. Yeah. Right, so yeah, let's not scroll down anymore. We're gonna end up with Frost looking at gross toes and stuff if we keep going. Alright, so what I think I don't want to study at the moment. I think I need to know graphics theory. Not knowing graphics theory right now is hurting me, I think, more than anything else when it comes to like what to implement technology wise. Physically based atmosphere would take a lot of work. You'd be better off learning physically based rendering inside out first. I see. So physically based atmospheric model requires this information requires you to be pretty good, if not basically no physically based rendering inside out to be able to do the more advanced stuff. Thank you. Where did you learn all these codes, and how? And do you know either? I can tell you the second question. I don't know Hindi or that other language, unfortunately. So yes, English is the only thing I can moderate. So yeah, please keep it to English. Not that you weren't going to. To answer your first question, if you want to learn how to learn C++, I would say pick something that you want to target for, like make a small tiny little game and then go to learncplus.com. C++. So go to learn C++ and then pair that with a not YouTube creator, sorry, one lone coder. Type that into YouTube. Unfortunately, it's all in English, but if you go from his older videos, let's say older, and you pick something that you might be interested in, like this, for example, making a first-person shooter with ASCII, making a Tetris clone, which is quite easy to do. His earlier stuff is simpler. So if you pair this is like what you should learn. This is a project that you can tackle with what you've learned. Someone has had success with this already. Literally, I can even show you. Look, someone is telling me that they've done really well. They've provided a GitHub link. I haven't actually replied yet, but this is exactly what they've done. They're getting really good. They add C++, so that's something that you could do. It's just a path you can take. But anyway, let's go back. Any particular reason to go with slang instead of GLSL other than cross-compilation on Metal and other stuff? Right now, I'm maintaining 2 versions of my shader, GLSL and MSL, and I'm considering slang. Yeah, it would be very tempted to actually make a separate project and work through, learn OpenGL tutorials in OpenGL, learn physically based rendering theory, and then try to implement the same stuff in Vulkan after then. I couldn't tell you with what the advantage of slang is. Completely fine to me. The only thing I've seen with the only downside of using slang, which is not really a big downside, is that the newest features in GLS in shader languages that come through Vulkan, I don't even know. Okay, so this is what I've heard. I might be wrong. The newest features that come in shaders come to GLSL first and slang later. That's it, right? It's not much of a big deal. So 2 books I can recommend are Real-Time Rendering 4th edition and Physically Based Rendering 4th edition to try to implement from theory to implementation. Yes, so yeah, use slang. If you want to use slang, I just like the syntax better in GLSL because it's very explicit, but yeah. I am not a vegetarian. And thank you for the reactions, guys. Okay, so Yeah, physically based rendering has a book. Sorry, we're going completely off the script. We're going completely rendering book. I think I actually posted this in the. Sorry about the brightness of this website, but it's. I am in dark mode, but if there is no dark mode for the website, it will just be white. So actually, wrong server. If I go to resources and go to here, just make sure this is the same website. I believe it is. Yes. So it looks like I can do the physically based rendering book, and for free for some reason. I don't know why this exists. So this might be how I get good slash yeah, so let's just make sure that this is the right thing. Okay, so this is the right book. Thank you for clarifying. This is the second book that you suggested, isn't it? I don't know, man. Slang is relatively fast to adopt new features. Slang is the de facto standard. Yeah, yeah, it's okay. Right. That's. Thank you for clarifying. JTag. Yeah. Okay. So, slang gets updated first, then adopted into Chronos. Okay. There we go. I don't know what GLS. I don't know what I got told, but that's what I got told on a live stream. So there we go. I'm glad we have other people here. So yeah, I use slang. It's. I've started to use a bit of slang, but I haven't just fully converted over. I don't really have any preference. Okay, so to be able to... Okay, so this is the notes I want to take. So to get... Okay, so I'm going to make another note here. These are my rough notes from live stream stuff that everyone's been telling me. Would you behave and do what I want? Okay, there we go. To be able to do things like... sorry, to be... I feel like to be able to do more advanced graphics when it comes to pure rendering. So this isn't like animation, so excluding things like animation. Right, so it takes a whole kettle of fish and meshlets, culling, blah blah blah, right? So just the actual, like, the colors. You need a strong base, etc. In PBR to be able to launch from that position to make things work nicely. Alright. I love slang, to be honest. Slang with modern Vulkan dynamic rendering and fully bindless resources with its descriptor heaps just makes my shaders so clean. No dirty layouts or binding. Oh, share that book link. Yeah, sure. I didn't see your message. So this is it's very maths heavy as far as I'm aware. This book, this is the physically based rendering. It's in the resources, but I posted it in the chat anyway. Where's the live stream? There it is. I will remove the preface. So there you go. Don't close that, so I can actually see if it's still live or not. Okay, okay. Okay, so I need to make a decision. Effectively. So this is graphics theory, which is completely chill. So we have a bunch of stuff to potentially study. And in what order do I need to study, prioritize stuff in? So IBL is fine with this physically based rendering right now, at least. I'm hesitant because I need better metal support too, so it seems like I need to look into this a bit more. Oh, okay, yeah. I know GLSL and HLSL cross compile for slang is good / great. My worry is I see. Right, I wouldn't know. Oh, okay, yeah, share the Discord too. Yeah, I will do that. I think the bot is broken, so I'm just going to do it myself. So yes, we have a Discord if people want to join. And anyone who wants to join can ask me at any points, and I will always sort that out for you guys. So there you go. This, for anyone's watching in the future, is like watching this as a VOD. That link I posted will likely be expired because it's only a 7-day link. But you can find a link on my channel. That there is a permanent Discord link on my YouTube channel which you can always access at any point. So there you go. No, I do not vibe code at all. Especially with this type of stuff, vibe coding is not very good. Just to give you a perspective, by the way, is just to, you know, if I was to scroll down into this, some of the stuff that we end up coding is like this. It's a bunch of like very specific mathy things that MLs just have not acquired into their knowledge set, so that they end up making subtle mistakes and it goes wrong. Despite the marketing, MLs aren't as good as they are made out to be. Hello, Mika. Thank you. Thank you for joining us just now. I saw you were live. I hope you had a great live stream, dude. We were live at the same time. I would have joined otherwise. But yeah, yeah. See you, dude. See you later. Have a good night's sleep. Anyway, so enough rambling. Not that I was rambling really, but I need to make a decision here. And I'm kind of putting it off. So the decision I have to make is, how far down the rabbit hole of physically based rendering do I need to go / rendering? Because if I go, oh, I'm really excited about this, you know, this type of thing, and I want to implement more advanced rendering to render like really nice lighting techniques or whatever, I'll be skipping out on doing other things because there's only one person. And at the end of the day, there is a particular problem that game engine devs, including myself, by the way, have, that they make the game engine and they never make a game with it, right? And that is something I've been trying to avoid by simplifying the game that I'm going to make and trying to launch that game, and then kind of incrementally improving that game. So I would learn OpenGL tutorials and learn the basics of physically based rendering, different lighting like Fong, Blinn Fong, and how to cook how cook torrents changed it, and how cook torrents changed it. Oh, I see. So cook torrents implemented. I just copy and paste physically based rendering code from OpenGL, from learning OpenGL code without deep understanding. Yeah, I want to avoid that because it's going to end up like, oh, I've done that. I want to. Part of this is also to become like a as good programmer as possible. So I'm a bit. So I'm going to mess up the game at some point. You'll figure it out, Mika, 100%. I saw your video, by the way. It's really cool, Mika. Yeah, I'm making Tetris first, then Battle City, and then maybe something like Contra. Hell yeah, bro. I love those 3 games. Battle City's underrated. That intro, oh, it's a killer.
I don't know it off the top of my head, but yeah, it's super sick. Anyway, yes. Will you use Visual Studios in development of the 3D game? Will you use Visual Studios in development of this 3D engine? Sorry. Yes. It is right here. Ta-da. Okay, so this is a decision. Ugh. Okay. Yeah, so let me talk through what I'm thinking, right? So let's run the game for a minute and kind of talk through it while the game's running. And talk about what the game needs. So at the very least, the game needs a 2D renderer. It also needs a way to interact with things outside of... I mean, we've got the basics down, so we can actually go like... Yeah, stuff happens. That's not the music, that's the game. Obviously, this is just a duck. This will turn into something else. So we have jolt physics. So we have a debug renderer, so we can turn this on and off, which, you know, every engine really needs for a lot of different things. What else do I need? So let's make a list, right? So yeah, I just want to be very forward focused with this. So I'm going to make some... Actually, I'm not going to use this. Let's make a second list. 6. Hopefully you guys are up for this. So what does the engine need? I want to do that. Maybe tab. Yep. Okay, so it needs a 2D renderer for UI and other stuff. It needs more entity interaction. So, I don't know, for example, if you crash into a rock, something needs to happen. Now, the other thing is everything's too dark. Everything is too dark right now. And what I could do very simply, the simplest thing I could do, is just bring up the base color brightness. And okay, so I'm not going to actually write solutions, I'm just going to write problems. Okay. I don't know what my game is going to be exactly yet, but I think now I really need to think about what the minimal viable product is and get that out of the door. I can always improve this later. This can always be like an ongoing project that I continuously improve, kind of like Vampire Survivors did. But if I release something, I've got to be very careful I don't break anything, especially if I put it on Steam. Like, even if it's for free, or like 1p, I don't know. Yeah, so I also need to think, this is just game stuff in general. So I'm just trying to plan this out. I also need to consider how to release this game and stick to it. It's possible I release this game for free, then. So what I'm thinking about with this particular game, ugh, God, please work. Nope. Let's start again. There we go. That's what I wanted to do. Release this game and make another one that's better. Alright. With better graphics, etc. And this is what I was thinking about this. Use the most basic techniques. Use and slowly improve the rendering with time. These are the most important. Absolutely. We can't even have a game. Fair. Yeah, the other two are. So I'll bold these for a minute. Okay. Because these are more important. Because it's really nice if I have like cool graphics. Alright, I'm just going to fix the music. I think it's repeating. I think if I do this, maybe I'll stop. So these need to do something. And it also needs to be... Alright. Okay, so what I'm going to do is talk to... Yeah, I need to talk to people about this. Like, game devs. Greetings, my man. Alright, so let's catch up with the chat. Last I remember, the RAM consumption is 0.9. And it's something like, what? What happened? The RAM usage almost doubled. Yeah, did I increase the RAM? Hang on. It's because... Why did that happen? Oh, sorry, up the top. No, it is. You're right. This is actually a bit bigger than I wanted. I think it's the jolt physics. Yeah. Let's see. Yeah. Let's have a look at... Let's reduce this. Okay, this isn't truly what it's going to be like if I open up Task Manager. But I am... let me compile for release as well. Let's see how bad this is. So it should be something around 1 gig. Can I be honest? No shade. I think Vulkan might be a little too much for you right now. If you don't necessarily understand graphics theory and rendering techniques, Vulkan isn't the answer to that. No problem. It's criticism is always welcome on my end. Only saying that because Vulkan has a lot to do with configuring and worrying about what OpenGL does. I feel like I could be arrogant in my statement here, but because I've been doing Vulkan for like a couple of years now, and I've only spent time learning Vulkan. I haven't done any graphics theory as well. I've got a graphics theory book and I've read it and stuff, but let's just look at this first before I keep talking. Yeah, okay, so it has increased by... Yeah, that might be the physics engine. Which is unfortunate, but yeah, this I have reserved 1 gig of memory.
A lot of the other stuff is Visual Studio's fluff on top of everything. But yeah, I should keep an eye on that. There isn't a memory leak. I've just let the memory kind of balloon a bit. You should know way more about Vulkan by now. When did I start learning? What was my first project? Well, it doesn't really matter where I am or not. What I need to do, honestly, is just get better than I am today. It doesn't matter if I've been learning Vulkan for 10 years since it came out. Yeah, I was pretty new to graphics in general. I kind of started learning. When was my first project? I can't remember. Like, my older projects are somewhere else. I haven't really kept track of when I started them. But anyway. When will you start developing the engine? I've already started. I think the basics of the engine are done now, and you're working on... No, it would be something like Unreal. It'd be something like a low-level E engine, if that makes sense. It's going to be just a little engine. I think you would benefit from both building a basic game in Unity or something that I've actually done Blend Fong lighting in the past. I just now use PBR instead. It's not that I'm using, I am using, Gust actually used Blend Fong. Wherever that is. Oh, it's, my older projects are actually here. That would be, oh, these are all such a mess. When did it? Sorry, I'm just trying to find out where my projects were. Anyway, since you're building this for Vulkan, I assume you're using GLSL by default. Yes, for a shader language. Do you have much experience with it? I'm getting into shader writing as an environment artist. I see. It's tough. The best resources for GLSL are books, are shaders. Right, okay, so HLSL is used for Unity and Unreal. I haven't used those engines. I found that when I was learning HLSL very briefly in slang, yeah, the transition isn't that difficult. Yeah, and JTag is saying, yeah, use slang, which, you know, is very good. Alright, so let's go, let's grind. What shall I do? What shall I do? What I'm thinking of doing then is doing this buck. Or should we... Let's see. Or we study Learn OpenGL for now. Let's see, Learn OpenGL. So I'm just trying to figure out what to study, because we've done a lot of like planning, and there's a couple of things I need to do before we start. I do want to study before we start diving into ripping this code to pieces, which is what we're going to do next. Alright, sorry I'm taking a bit of time to think, because what I've been learning at the moment is this. So we could finish this off. But I think what I need to do before that, if I do that, is maybe start here. So I've already kind of gone through this before, with the subsurface scattering and all that kind of stuff. Because I've got a BRDF solution and all that kind of stuff already. Let me just think for a minute. It's not the best though, I have to admit. My solution. But I don't think neither is this. I think this is just a direction of pick something. Yeah, I'm really motivated to learn graphics theory right now. Alright, I would make a fresh Visual Studio solution and follow through with this. Follow through with, doing DirectX and stuff. If you use DirectX or 12. What are you talking about, sorry, JSAG? Are you talking to someone else? I could be completely off here. Alright, right, where were we? On our study. So let's bring up the graphics theory stuff, which is very weak. No, that's not what I wanted. Okay, yeah, so what I'm going to do is... Yeah, we're going to have to go through this, I think. I've already gone through this, but I didn't take any notes at the time, which is probably a really bad idea. So we're going to go through this. It's going to give us some... I will know most of this, I think, but I don't know ambient occlusion very well, admittedly. I do have ambient occlusion in my renderer, but I haven't really used it with anything. Oh, now you're talking to me. I would start a fresh Visual Solution with OpenGL tutorials. Don't worry about the game or game engine. Learn full from the website with OpenGL. The best way to learn is to do, then do it again and again and again. Yeah, let me think about that for a second. Should I just take an extra 4 years to do this or something? Or whatever it is, to actually get up to snuff and not make a game? Or should I... It'll only take you a couple of weeks. Let's have a quick look. I don't believe I could be completely wrong, but I don't think I'm as hopeless as you might think I am when it comes to Vulkan. JTAG. Hopefully I can say that without causing offense. But like reading this and then reading that and then reading this afterwards, that would take me a while. And then reading everything that I need to do with this, that would take me that's what I'm talking about. Like, yeah, this would take me ages to do all these three resources together and be making stuff at the same time that's getting more and more advanced. I could integrate... Sorry, I'm just trying to think. Yeah, that's what I mean. If I was to keep increasing the complexity of this engine over time, that might be a way of doing it. Yeah, so what I need to do is just pick something that makes sense for me right now. Okay, so we can get rid of this. You're not exactly that bad at Vulkan, but you did say yourself you wanted to be able to answer the questions better about stuff which you cannot answer. And you should actually know after learning Vulkan. Sorry, will we do that again? You are not exactly that bad with Vulkan, but you did say yourself you wanted to be able to answer questions about this stuff which you cannot answer, and you should actually know after learning. Yeah, sorry. What I meant to say is I don't. If someone came to the chat and said, "Why do we have destination image used for a texture or something like that?" I wanted to be able to just immediately simplify it in the sense of like a Feynman technique when it comes to learning, right? So that's what that idea was. More than I didn't understand what it was. I wanted to be like as concise as possible because I know exactly what it is without any fluff. Because I could tell you a lot of things. In my video, I talked about this. I talked about the fact that I'll just bring it up, and then we'll actually get into something. In this video, I talked about like, the basics. Like let's just say a boxer, like will still go over the basic footwear basic foot movement techniques, like basic jabs, even if they're a professional fighter, right? That's what I mean by like going over the basics. Like it's never going to stop. I'm never going to stop going over the basics, and I want to get sharper and sharper and sharper at that particular, being able to do the basics as like well as I possibly can. So I think we're on the same page when it comes to like learning OpenGL from scratch or whatever. I just don't want to do it with OpenGL if I'm going to do this at all. I think the approach that I'm going to take is not going to be like that. Because I think I can do stuff. It's not like I'm completely lost or whatever. But there is stuff that I can't do, like, for example, I don't know how to shadow map. I don't know how to do a spotlight versus I can do point light. I don't know how to do light clustering. So there's stuff that I should know, in theory. Air quotes, I should know this. Like, what I should know and shouldn't know is kind of subjective to whatever you want to say is a good or bad thing that I should know or whatever. I'm not going to say that this or that. Yeah. Yes, the answer is yes to that. I mean, I've already done it. This is completely separate from the Mastering Graphics Programming book. I haven't done any of this from that book in a while. I haven't looked at that book in a while and at all its source code. I still use it. I still use some of the stuff from the original, like, because there's no point of throwing it away and doing it again completely, because I'll just be typing it out from memory. Okay, so let's think. What is the best way to do this? Let's get rid of this. I mean, a lot of this stuff is It doesn't use like the render passes, for example. I've pulled out the parsing of the. If you don't know, Mastering Graphics Programming book had a bunch of parsed. You basically made a JSON file that told you how to handle streaming of resources when it came to your graphics pipeline layout. I don't have that. I ripped that out because we do something different now. I don't have render passes anymore. I've got the DAG still, but it's not with render passes. Well, a primitive version at least. Yeah, so there's a bunch of stuff in here that's not even similar at all anymore. Can I ask you something? And feel free to tell me to F off if you don't want to answer. No, it's fine. It's sure. Yeah. I don't know what you're gonna. Yeah. I might not answer, but I probably will. There's I don't think. All right. Let's dive into this. I think. What I'm going to start doing, I think, is I don't want to learn. There's like 3 things I want to do. Right, so what I'm going to do then is, no, we don't need to do. Yeah, let's go through OpenGL tutorial. That's fine. I don't need to do this. I already know all this. How long did you work as a C++ developer in your previous role? 6 years. And what was your title? Staff C++ engineer. But it was nothing to do with graphics. I had to learn that on the side. So I was like a mid-level C++ engineer. And yes, I never got promoted because the company was really small. No, I don't want to. I don't. No, this is just no. I think the theory's good in here, but we're not going to do. We're not going to just learn OpenGL and then learn Vulkan. That goes against my own advice. Yeah. All right. So what I'm going to do, I'm going to change because I'm kind of faff. Like, whoops. Okay. What's that? Let me. How do I? Yeah. I'm just going to log in. Just give me a moment, guys. I was just going to change my timer. Just logging in. Reactivate this. Doop. Hello, welcome back, guys. All right. Yeah, I'm gonna change tack and we're just gonna do programming right now. I'll think about this stuff later. I mean, you can use Vulkan for sure, but I would still recommend a new solution and focus on graphics techniques so you can learn them, etc. Sure. Yeah, thanks for the recommendations, by the way, JTAG. It's always appreciated when people hop in and give me some stuff to do. Right, so what do I want to do here? Hi, Cody Banana. Yeah, I think we're all good. So I want to break this up because this is a complete mess. This is the task that I was going to do later, but I feel like doing it now, so because it is a messy project. So I think at the very least we're going to make a new file and we're going to throw this into just game. Like, I don't know what to call it right now, but we're going to make a... Yeah, a lot of the, just so people are aware, a lot of the stuff that I did at my company was not graphics. In fact, none of it was graphics. The only graphics I ever did were right at the beginning. And I wasn't even allowed to do anything to do with actual OpenGL. Like, that was considered too advanced because I was like brand new at the time. So I was working with something called Qt's yeah, what was it called? QML. And I made a renderer with QML, if you can even call it that. And we had to compare it against OpenGL, and surprising no one that OpenGL won versus QML. So yeah, a lot of everything I've learned hasn't been at my job. It's been, you know, outside of that when I've got home from work and stuff. When it comes to graphics, like specifically graphics, why is this selected? All weird. All right. So if you're thinking like, oh, why does he not know this or that? It's not because I've like my job. I was 6 years at what's it called, like Frostbite. Okay, this music is definitely repeating. You know, a lot of the stuff I did was C++, but it was nothing to do with graphics. The graphics I did were software rendering at the very least, and even then I didn't touch it that much because it was already implemented. I think we've heard this song multiple times. Let's click on reload. Okay. Oh, hang on. Before we do this, I actually need to push all this code up because we actually got something working. Yeah. So let's make my GitHub look less amateurish. Added basic communication between the physics engine and the game code. Yeah, so game is just empty for now. Maybe I'll push that up before we start anything else. If APIs like Vulkan handle very low level stuff, why is graphics programming still difficult? Might be a stupid question, but I was wondering. Graphics programming is a subfield of like applied mathematics almost. And it's almost like it's like a cross between physics and, so, you know, if I throw in like this, for example, yeah, I'm kind of obviously skipping a bunch of stuff, but with like physically based rendering, we have to figure out like how light works, and the formulas get more and more complicated because we have to do this kind of stuff, and then that has to be translated to shaders, which is, you know, and then we have to do it in an optimal way. So the graphics theory itself is like almost, it's like, yes, you can learn them together, but they, as far as this is my opinion, it's maybe not the best opinion, I guess, or whatever. You can call me out, fine, that's cool. But with this type of stuff, it's like learning Vulkan alone. For example, let's just say you're like learning C++ for the first time, you've learned Vulkan. Like you learn more than just Vulkan when it comes to rendering Vulkan, and that is why it's tough, because it's like, you know, you learn something like, for example, React when it comes to like learning a website. Like to code a website, all you need to know is React, right? That's obviously other stuff and APIs come into it, but it's not like you have to know maths and how light works properly and how to like build acceleration structures for ray tracing and all that kind of stuff. It's you know, that like the theory and the graphics kind of have to like mesh together, because it has to be performance as well. So there you go. Hopefully that explains that, and you know, feel free to disagree in the chatteroony. Right, so game. Right. So what I want to at least do is, at the very least, I want to basically pull out everything of main. We're gonna get rid of everything in main. So the goal here is to have three loops, right? Sorry, 3 function calls: initialization loop or game loop and shutdown. So that these are 3 functions I want. At the very least, this is going to take like 2 seconds to implement, really. The question is, do I want... How do I want to do that? Because now we have a translation unit. Game. Okay. Yeah, coding is awesome. Yeah, it's if you guys are into graphics, please save your soul and take a look at... Oh yeah, you were telling me about this, I think. NVRHI. You don't have to use it, but it's worth studying, especially its public interface. Thank you. I'll write that up, actually. I'll write that in my notes. I will throw that in here. Potentially a good interface design. So potentially a good is RV for graphics. I'll look into that. Thank you for that. These are all my notes that I'm going to do. You might do studying later today instead. Okay, so 3 function calls. We want void int it. I can have that. Void shutdown. Let's see if we can get away with 3 free floating functions for now. And void loop, I guess. I might rename that. But yeah, my project, I think people have been criticizing me when it comes to my project. Because the first thing they see is main, and they go, what the hell? This guy just started coding yesterday? What the hell's going on here? So let's try and fix that, hey? And... which is fair enough. I mean, this is a mess. I'm not going to lie. What do I want to have in main, though? That's the next question. Okay, so what I'll do is I'll pull out literally everything and then slowly kind of make sense of this. Yeah, so that's what I'm going to do for now. We'll refactor this kind of in bits. So this is the first thing, move everything out of main, and then we'll split it up into something that makes sense. So we'll throw this here, we'll have the shutdown code. Here. So using int main is something that only beginners use. No, that's not what I'm saying. It's more throwing everything in int main is fine until your project gets to a certain size. And my project's got big enough that it's hard to figure out what I'm doing. And for my own sanity as well, it's getting to the point where my projects are getting big enough that people are looking at this code and going, I think, like, what is happening? So what I would recommend for anyone who's got everything in main, use main as long as you can. This is just an opinion, again. You may disagree. Until it starts to not make sense anymore. I wouldn't worry about what other people are saying, but as much. But I've always had a small main. The thing is why I haven't moved everything out of main already is due to the fact that
it hasn't become an issue yet. But it's starting to become an issue with this new entity deletion thing and working with jolts and all that kind of stuff. Like it's getting hard to keep track of things, and that's when it's like time to move on. And also, you know, and kind of, you know, there is some valid criticism to my code at the moment when it comes to how messy it is, which is completely understandable. So that's my opinion on that, because even in my old job, we had mains that were quite big. They did a lot of setup code. They basically launched a bunch of applications that would like talk to servers and stuff. So main was still doing a bunch of stuff, but you know, for aesthetics as well as organization, feel free to, because this is game. Like, let me show you like what a good main looks like. I'm gonna pull up a video just so I can show you what I mean. Let's go to my liked videos. It's kind of a joke video, but I'll show you what like a good main looks like. Okay, so it's this low-level guy. Where was the joke video? Okay, so I'm just going to show you this. I'm not going to play for very long, but like basically at the minute, he makes this joke that this code is too easy to read, so he's going to make it complicated. But I just want to show you the actual code base. So this is all main. This is all in main, right? Like if this main is as simple as this to read, then this is what main should be, right? Where is a good snippet where it just kind of stays still for a sec? Because it is a video. Ah, there it is. Okay, let me start again. Nope. It's an April Fool's video. Yeah, so if this is main, then you don't need to do anything with it. It's just my main is doing, it's handling a skybox separately. It's handling building pipelines, it's deleting entities. It's got too much stuff in it, so that now I need to think about like organizing my code a bit better. You know, it's way overloaded. All my code is overloaded. But I'm also like, don't design ahead of time. Only refactor when you need to. And I actually need to. Like, don't try to design something that's what I'm trying to say, right? Don't design everything ahead of time. That's what I've been told by other programmers who are better than me. If you think I'm lame as a programmer. Okay, so the next step is to figure out a place to put everything. Yeah, I think I'm gonna have to just for simplicity's sake make an object here, so I can just store objects. So hopefully that clears stuff up, right? If it doesn't, let me know and I'll try and explain a bit better. Yeah, it should be simple for you to work on, to put it in, to sum it up in one sentence. If it's not simple for you to work on, then, you know, fix that. Okay, so next thing I want to do is throw all my objects that I use in 3 different functions into 3 different places. So input handler needs to be constructed by the default constructor. And now we need to pull stuff out into the header file. What we do need for that? Input, right. Cool.
And device creation, GPU needs to be moved out, there's no doubt about that. Okay, so GPU device. And next is the profiler, which I kind of need to get rid of anyway, but it's still here. Profiler, which I don't even use, to be honest, but yeah, it's there. And I'm GUI service. Where's the actual? Okay. This is a pointer, which, you know, it's chill. I wonder how that's gonna run. I'm gonna try and be sneaky here and see if I can get away with doing this. Is that possible? We shall see. Okay, so what was I am GUI on there? Okay, there it is. Okay, let's take the... Yo, Shadow, how you doing, dude? What else we need to do? Okay, so we got intit. What else are we missing? We're missing full screen, which is just here. So I think we need all these out. These need to be variables. And I as well. Game camera. Do we use this anywhere? Yes. Okay, so I'm gonna grab all these variables, obviously organize them later. In fact, I'm gonna just make sure this does not be something stupid. So on the IMGUI side of things, right, here we are. So I'm going to throw this in here and just, whoops, GUI. Okay. Now, obviously, my header doesn't make any sense anymore. Okay, so get rid of this and this. What is this doing? Do we need all the structs? That's the next question. So, scene. Oh, hang on. Yeah, now we've got to be careful here. We've got to make sure we don't shadow our variables. Otherwise, we'll end up assigning some local variables that and have uninitialized memory. We don't need this. That'll be constructed ahead of time. I think we need this and something like that. Do we have I? That's the next question. No. Oh no, we don't. Okay, so that's fine. Get rid of game camera. We don't need I here anymore. This should be like that, if it exists. Yes. Okay. And okay, so we have creation. Right, okay, so let's see. What are you trying to work? I'm trying to refactor my code so main doesn't have anything in it. Well, apart from like one object and 3 function calls. Because right now main has got completely out of it's gone crazy basically. Where is scene created? It needs to create oops. Cool, thank you for letting me know about this. I'll reorganize everything later as well. Don't want that. We need audio system in here. Maybe we'll make these all pointers. We'll get back to that in a minute. Yeah, because my GitHub repo is probably like putting people off understanding what's going on at all because everything's kind of a mess, which isn't good. And I've kind of let it get that way deliberately. It's not like I did that by accident. So do I need this here? I don't even need this. Do we use this anywhere else outside of a function? Yeah, I think we could just throw this in here. Make our lives easier. Cut this out. Throw this in here. Oh yeah, I made my first C++ program. It was a Tetris game. Yeah, I saw it. I saw your messages. I actually showed people in the live stream earlier, like how well you've been doing. Because someone was asking how do they get into programming, and you're doing fantastic, by the way. Which is great stuff. Like what you're doing is exactly what you should be doing, in my opinion, to learn C++. Combining both a Tetris from one lone coder and improving it / making it your own with Learn CPP knowledge that you've picked up. Yeah. Yep. Showing everyone. Yeah, someone was asking about how to code. Yeah. Right. Right, so we've done that. We need scene. So this works apparently. We buffer creation. Okay, so buffer creation's up here. So we can. It's such a simple little guy. We need push constants out of here though. It doesn't really matter. We can just reuse it. It's here as well. So push constants. No, it's in this stream. Yeah, I just went. Also did is I went into your messages and said, yeah, Shadow has done really well making this program. Now I can even open it up. This is, if you're learning C++, this is what you should be doing. You should be improving it, making stuff your own. This should be the scale of your projects, and the stuff you're doing is fantastic. So yeah, there we go. Did it again. There you go. And actually, to go back to this again. Actually, you know, I'm taking everything out of main. This is what a main file should look like if your project is this size. Everything's in main, right? Everything's in main. This is exactly how main should be used. It only makes sense to move stuff out of main when you can't follow what's happening anymore, when you need to organize stuff. Don't pull stuff out of main unnecessarily. This is exactly like... I was trying to show people earlier with the video, but this is actually a better example because it's I can show you the code. Everything's understandable. It's all just in one place. Yeah. Right now, everything is not understandable in my code, so that's why I'm moving stuff out of main and trying to split things up a little bit. So that's actually a really good example of what I was talking about earlier, about having main be, you know, used until it's not useful anymore. So yeah. Yeah, you're doing all the right stuff. Okay. Is this repeating music? Oh, the shuffle's off. Let me press next. Yeah, no problem, dude. Yeah, just keep it up, dude, and you'll keep crushing it, and you'll eventually be a better programmer than me. So, so push constants. Push constant. Where is this guy? Is this okay? I think again I can just get away with doing this at runtime when it's needed. Yeah, just like this. Because if it's used here and we just build it up, we end up overriding all the data fields anyway. So yeah. Okay, so skybox handle is there. Okay, that's very simple. We'll just pull this out. Okay, skybox texture handle. Now that can be used. And a few shutdown commands are left. And we have the array, which again can be, because we don't allocate it, it's actually completely fine to throw this over here. And yes, we're doing this very scruffily at the moment, so there is that. Sample a skybox. Okay, so do that, and now we should be good. Alright, cool. So this should compile. If I just compile this file itself. I think it's F7. Yeah, that's just compiling everything. Game int is legal. Huh? Oh. Right. Didn't catch that. I was like, what the heck? Let's just build the whole solution. Right, okay, cool. And this is going to be a very straightforward object. It's going to be massive though. Alright. I could put this on a heap. Maybe I should. But we'll see how the stack handles this. Int it. Game loop. Game shutdown. There we go. Very nice. It still hasn't cleaned up the code very much because we just moved everything from one file to another, so that's not complete yet. We haven't yet finished. That isn't the entire thing. And we've also got to make sure it works. So let's see how we go with everything moved. Yep, sounds good. Everything shut down's fine. Fantastic. Okay, so we are one step closer to having code that's readable again. Right, okay, so let's keep going. Actually, I need the toilet, so I'm going to be right back in a minute. So I'm just going to put a BRB, classic note style. Or if it... Look at that, I did my graphics myself. Alright, yeah, so be right back. And we'll keep creating. Hang on, let's turn this off. There I am back. I just had to go to the toilet. There we go. Alright, let's figure out how to fix this a little better. So we've got a bunch of stuff in here that I don't like. So we got some global state set up here. Okay, let's work through this. Okay, Okay, so the first thing we should do, I think, is just organize our header file, because it's a mess as well. So all the booleans should be together, and they should be at the bottom. Yeah, so let's get this. Let's shrink the size of the struct down. Okay, so input device. Texture handle. So I need to figure out the 24. That needs to be above everything. Well, at the very least. I think GPU device is going to be the biggest struct. Yeah. Okay. So it's massive. Next is input handler. I guess we could initialize this as well. What about you? You're pretty big. You're bigger than this. Alright, and this is going to be a pointer, so that's going to be 8. 8, 8, 12. So what I'm doing here is organizing this so the memory layout is better for the... So when we fetch this memory, it's not all being fetched out of order because there's a bunch of gaps. So yeah, 300, that goes, yeah. So this helps with memory locality. Because it makes this, it's going to make the struct smaller if you don't have big gaps. And generally, it's really simple, you just order the things from biggest to smallest. So this needs to go here, where is it? Yeah. And then I'll label things 4, 12. So these need to, oops. But still, this isn't great. You use classes, you use structs like classes, yes. The only difference between a struct and a class in C++, you may already know this, but the default access pattern is public. With a class, it's default private. So it depends on what you want in your setup. So 600. All right, so that's about there. Might make sense to make these all pointers, to be honest, but we'll see. So it makes the struct smaller. I really don't like this skybox array just sitting here. Skybox code. We need like a skybox class, I think, that kind of deals with skyboxes separately, or struct or whatever. Because this being here is kind of silly. So I'm probably going to do that next. To like pull out this code and make a skybox specific thing. Okay. Oh, did I cut audio system out? I did. Alright, let's just put that back in. Let's just absolutely make sure it's not here twice. Yeah, okay. 48. Okay. Has to be moved one down. Yeah, for structs I like to keep data driven, so for classes I use them. Nice. Yeah, it's and for classes I use it as a class itself though. Yeah, that's a totally valid way of coding. There's no wrong solution. There's no wrong way of coding really. So we should have shrunk this guy down. Yeah. Anyway, let's think about how to do the skybox then. Yeah, this is just dumb, in my opinion. I've left the skybox floating around. Just trying to see where the skybox is used. So there's the skybox data. Yeah, so we're gonna have a. Yeah, we can't have this just in here. This is just dumb. It doesn't make any sense to have this all initialized in one place. So the thing is, where does this need to live? Yeah, it's pretty opinionated. The only difference is the struct is public and the class is private by default. Yeah, it's pretty much it, yeah. It's nothing you have to worry about. I just don't use encapsulation. You're probably familiar with in C++ to know what that is. Yeah, so where should I put skybox? That's the next question. Actually, we've just changed a bunch of stuff. Let's see if it runs. Yep. I'm not surprised that didn't break. Okay, so where should skybox live? Should that live in graphics? We have like core here, and then we have like non-core stuff. Alright, I think I'm overcomplicating. If I just put it in here until this gets too unmanageable, then yeah. Alright, yeah, that's what I'm going to do. So I'm just going to make a skybox struct file and all that. Graphics. Simple. Keep it simple, stupid. Okay. I am very familiar with object-oriented programming in Lua, though I have been strict about data types. Nice! Well, there you go. That's going to give you a massive base. Let's make another file in graphics. Duplicate these. Right, next is to regenerate. Okay, so we have skybox, if and def. And we're going to throw in everything to do with the skybox in here to reduce the size of game in this case. Alright. So you don't go in here and go, why the heck is everything, tons of stuff to do with skybox in here. So okay, so at the very least we need to get rid of, how am I going to do this? I need a skybox. I think I need a skybox object with int its So when I actually run this, I don't want to run this. So here's the actual code. Yeah, I'm going to have a int it, shut down, and draw in an object, I think. Or can I get away with a... I might be able to get away with just putting everything in... Because I think most of this is plain old data stuff. So if I just look up Skybox... let's just have a look if there's any... So there's pipeline creation, which can be done by itself. However, Lua has dynamic variables, whereas C++ has static. It's... I think you mean strongly typed versus weakly typed. Both are case sensitive though. C++. However, C++ honest about the machine. Yes, in Lua, you're capped by the Lua VM, and you filter out exploiters, injectors, and malicious code into the compiler. Nobody can get hacked on Roblox. I see. Interesting. Okay, so yeah, pretty much. You have auto though. I don't know how far you got through C++. We do have runtime type deduction with like auto and stuff in C++ now. So in theory, you could just start using auto everywhere. Don't recommend doing that. Yeah, so this is going to be a pretty... I think I can use like 3 functions instead of... there's draw and there's shut down. Yeah, so I'm going to make 3 functions rather than for, an object. So void inted skybox, and then void draw skybox, and then void shut down skybox. So that's what I'm going to do. Okay, so throw these in here. And there we go. And now we need to just grab every skybox related thing out of here. Okay, so this includes this function. It includes a lot of stuff. So in the CPP file of skybox.h, I'm going to throw in everything here. Get rid of stuff I don't care about. And push constants, don't need to know, I don't think. We don't use a push constants in the skybox code. Oh, I'm lying, we do. Why is this here? Oh. Right, okay, so this is the global layout. Okay, so we do actually need that. Oh, do we? Hang on. Let me look at my drawing code. No, I'm going in the wrong place now. It's going to take me a minute to not go to main to look at this code. When I bind the graphics pipeline, what do I set up a push I do. Okay, so yeah, it might make sense then to let me think, because we have 2 versions of the struct, which isn't good. So I'm going to have to grab the there's something interesting I want to say. This would apply to any programmer. Yeah, pretty much. There's something interesting I want to say. This would apply to any programmer. Yeah, to make actual good code, you should make it functional, make it right, make it beautiful. Yeah, pretty much. Yeah, I can 100% agree with that. Although some people, in my eyes, this might be the only thing I disagree with. The beautiful side of it is some people go overboard with making things beautiful. It's like, you know, people need to. It might sometimes, not always. Yeah, maybe I'm saying that because my code is ugly right now. But yeah. Yeah, don't get hung up on beauty too much. Skybox. Because you can go down like a bit of a rabbit hole of like everything must be beautiful. But yeah, everything else I 100% agree with there. And even what I'm saying there is just a caveat, without a doubt. Okay, so let's get the drawing code out and throw this in the skybox code and the initialization code. Yeah, it's pretty subjective, but it's beautiful. Yeah, if you understand it. For me, what I would call beautiful code is like someone who's kind of new to C++ can just understand what I've done. You know, there's no weird syntax or advanced C++ rules that I'm using. And also it can be translated to other languages quite easily because of that. That's my idea of beauty. But right now it is not beautiful, my code. So we'll get there though. So we've done the rendering, we need the initialization now. So I'm just going to copy all this. Is there anything else up here? No. Copy and throw into here. And we don't need this. We don't need scene. We don't need to do any of this. We just want skybox stuff. We don't need these two. I don't think I need this. I hope I don't need that. Skybox. Then we have a descriptor set for both. Cool. Yeah, we build up a cube map. Now we need to get rid of these guys that are just kind of floating around. We only want cube and skybox. And I believe we don't need these guys. Oops. Okay. Do we use this anywhere in here? No. Okay, right. Right, we've done that. Okay, so now we need to start adding includes. What do we need here? We need, I'm going to keep going to main for a long time. So we need them. Right, I'm just going to kind of throw this into Notepad for a minute just so I can keep this page up. There we go. And what else we got? Project files don't need to be organized or over abstracted. Yeah, 100%. People, I think I did that early on. Like I did that a lot early on. So when I was like kind of learning to code, I would like design like the perfect interface before doing anything. Yeah, I think you can just write code that is more honest to the machine, but white spacing does make it easier to read along the way. Yes. So all I'm doing here is just literally going to I'm just making my job easier in the future. I'm not doing anything interesting, moving code around. We need a GPU device. No. I want as few includes as possible. I think we need a GPU device though. Needs to be slash graphics. Oh no, it will be. Whoops. So go to skybox.h. See what that puts us. So we need file read. Okay, so the GPU device needs to be in here. And so that's pretty straightforward. Put that there, and right, that's the draw. Oops. And we need the file include. Even I used to over-engineer a lot of stuff with my Lua. I think that is transferring well to C++. Oh yeah, your knowledge from previous, yeah. It will do. Anything that any programming experience, even if it's like scripting, it'll help a ton. Yeah. Okay, so let's get the file. I did it again. Let's grab this. Where should I put this? I'll put this here, I guess. So I'll get rid of 2. Oh yeah, we need go to Skybox, go to game, sorry. Where is this? We are missing the debug pipeline. Oh, the debug pipe. Why is this here? Oh, I've included. Right, yeah, I've included this. I don't need this. For this array, I believe, is it used anywhere else? No. Okay, so let's move this. That's one of the reasons that I don't like AI code. You can understand the bad code from humans immediately because it's a byproduct of an unclear understanding of something, about something. AI just structures it cleanly and creates an illusion of clarity. I like that actually, yeah, it creates an illusion of clarity. That's a really good way of putting it. Yeah, it's like super clean, the code, and it's like, it makes sense, and then, but it's like broken in a very subtle way. Yeah, the illusion of clarity. Damn. Okay,
So if we go into game. Throw this in here. These are just numbers. Let's throw this in here. I mean, this can be stacked. It doesn't really have to be. Yeah, it's just a scratch allocator. Oh, right. Doesn't need to be shut down then. Okay, so this is a bit more heavyweight though. This can be scratch. I think it's a good idea to put this on a heap because it's a big fella. Oh yeah, I actually followed up with a message about Carmack with AI code thing. Is that what John Carmack said? Huh. I'm not surprised. He's like one of the best programmers ever. Alright, let's fix the shutdown code. Okay. So we also need the GPU device again, but we also need the command buffer. So for the GPU device, unfortunately, we're gonna have to include. Yo, how you doing, dude? Good to see you. Hope you're having a great day. Now the message about what I synthesize if I program is not clear in my head. I see. So you come up with that. I won't credit John Carmack, then I'll credit you. It's really smart with the, because I don't use AI code, so you know, when I see AI code, I just kind of see like, wow, that kind of looks clean, but yeah, that's it's really interesting. The way you put it is really good. We don't need this. This is just a constant out thing. What else? What else are we doing here? Oh yeah. So we need GPU device and the command buffer included in the header. Otherwise, these functions won't work. Oh, it's the GPU command, I guess. Doesn't really matter. Why I say it's unfortunate, it's just a big include. Include. Honestly, I do have a bad taste in my mouth with AI code. It can be used, but it's faster to write. It's faster to write code when the language is clear in your head. Ah, I see. Yeah, Carmack never liked to import libraries. Wow, it was faster to him. Yeah, of course it was. Carmack's just goated, honestly. It's just so good. Oh, S commands. There we go. Alright. Okay, we'll just change this to dot. Okay,
You also need the global debug data, which is... Okay, so we're going to have to build a... abstract this out into two different, like... So right now we have this, like all these structs kind of just hanging out. And these are going to be global to different files now. So we need like the data. Yeah, he is. Yeah, if I had a crumb of his intelligence, it would be better than mine. It's so good. Okay, so what is in Skybox then? This is going to be the most stripped down version. At the very least, we need debug data and this is kind of tricky because this is the actual buffer itself. Why do we write this? Alright, gotta go. Bye. See you, dude. I'm just thinking, sorry. What do I want to do? So we have this uniform data guy. Global data. And this is kind of tricky because it looks like in my shader for the skybox, which is down here, we are uploading... What are we uploading? Scene data? And that must be what it... That's gotta be what it is, right? I'm kind of curious, like, what would happen if we got rid of this? We just went, nah. And I'm gonna lazily just pass in the push constants data. Have you tried SPRV cross shader reflection? Yeah, probably about... I did that with a lot of guidance, and I did that about a year and a half ago now, maybe 2 years, so I won't be able to answer any questions if you've got some, unfortunately. But I have done it. It was fine. I did it very basically, and I had like a book to tell me what to do. Yeah, so my knowledge is thinner than it should be if you consider if you're looking for like someone who's actually gonna help you with that. But because my graphics pipelines are so small, are so thin nowadays, that I'm trying to avoid doing it. If that makes sense. So I don't want to be. Okay, so what's push constants? Oh yeah, this is a struct. Let's think for a minute. So we have GPU resources, which has a bunch of stuff in. Do we even use this anymore? Yeah, I don't think we do. Because I moved away from this idea. I just started to write these things myself. How about this? Do we use this? Nope. Why is this all here still? I swear I got rid of all this.
Yeah, I stopped using reflection because people in this chat were telling me that my graphics pipelines were too simple, that I didn't need it. So yeah, JTag's really sharp, so he'll be able to help you if you have any questions. Assuming that you want to help, by the way, JTag. I don't want to offer you up if you you know, you just want to ask one question and dip. Yeah, I'm trying to think where to stick this. Where to stick all my... I might make a class called shader structs where we just have all the shader structs in and we just include them. So we can have them in different files. Yeah, I think that's what I'm going to do. Okay, so shader data maybe. Yeah. I'm generally curious because since I use a method, I use materials, pipelines, so I already have a mechanism that I know required inputs for the input shader. Yeah. So no need to reflect. Yeah. And I don't need to know the binding offsets and descriptor heaps and all that kind of funny bindless race. It's exactly why I stopped using reflection, but I use buffer device addresses instead of buffer heaps. Yeah, people were saying like, well, you've simplified. Well, I think it was Ratchet actually was saying, which is someone in this chat. If you don't know who that one I'm talking about, it was like, you know, if you use bindless enough, that the graphics pipeline creation and your material and the way you're doing your materials, if it's all bindless, then reflection is less needed. But you might need it for something else. I don't. Oh, no, I haven't been timing myself. Okay, so let me fix this quick. So I came back from the loo probably a minute after that. All right, cool. Yes. Yeah. I don't see... Maybe you can argue your point here, but I don't see the need for buffer heaps at all. When you've got buffer device address access to... Alright, you're going to break some breakfast, no problem. That's why I decided, nah, I don't ever need to touch heaps. Yeah, have a good breakfast though. It just seems like making that like using a table to access data instead of just having a way to just access the buffer directly, almost with a pointer. Just seems a bit of a extra layer of abstraction that you don't need if you have push constants with a bunch of pointers in to that data. Alright, so shader data. Okay, so this is going to be the simplest thing for now. Oh, no. Alright, cool. Next is the structs that we need. So what do we need in here for our drawing? We need the push constants, data. Okay, at the very least we need to be able to access it in a different place.
And go to game. I'm going to steal this. And we're going to put it in here. We obviously, yeah, okay, so we need what do we need in here? This is just plain old data, so we need platform, foundation, include all these things. We just need vec3 as far as I can tell, but we're gonna likely need the rest, so I'll put these in here for now. Okay. Oh, not sky. What am I doing? I put the wrong thing. Push constants is the thing I needed. Ugh, idiot. Alright. Alright, I'll leave these in here anyway. These are included with... Alright, I think we got the same like 4 songs over and over again. So let's pick... Yeah, something like this. Yeah, so that hopefully should stop repeating things. Alright, so where is this? I kind of don't want to include literally everything. I wonder where this is defined. Yeah. Yeah, then I just include this, lol. But, okay, it's not in there. Yeah. Okay, so let's get our plain old data in here. Good. Yeah, that should be everything. Yeah, it's in Vulkan core. Is it worth doing it this way? Alright, I'll do that for now. It's not that much harder. Okay, so now I can go into here and then include shader data, and then we have access to that struct. So definitionally speaking, the next task is going to be... I did it again. Where is this push constants created? So we create... okay, that's what that is. That's nice. It's the C address.
Alright, I'm just gonna throw everything into this and then kind of work backwards because I'm not entirely sure what we need and what we don't need. So yeah, we're gonna have a buffer in there. We're gonna also have the push constants guy. I have a feeling that it's going to be... Right, it's so small, I don't think we care if it's a copy. Okay, so I'm going to throw this back in as well. Just needs to be a pointer now. Uniform data. Is that the same thing? Oh, idiot. Global debug data. Why is it called that? Yeah, this is. I'm glad I'm refactoring. Holy moly! I think I might have called it the wrong word. Yeah, this is scene data, not debug data. Alright, let's just rename this. Scene. Alright, cool. And this comes from uniforms, so I need to put this in the shader data. I'm going to need more includes now. I'm not going to believe those are there. In fact, I'm just going to re-grab them out of our crappy function and throw them in here. No, scene data, wrong. This goes through them in there. So that should have vectors as well. I don't think we need. Is that a thing? Yeah. Alright. Alright, whatever. I keep doing that. So we're going to include. So push constants is where? Yeah, so we can't put that there now. This doesn't exist in here anymore. It's in struct data, and I think to make this work, we need to pull this out. Put this here. Yeah, something like that. So we at the very least know what this is. This is a buffer. This is global scene data. And there we go. And if we go back to our game class, I'm gonna rip this all to pieces in a minute, which is gonna be nice. Just gonna make sure I'm passing the right data in to this guy. Global. Yeah. Global scene data is not the same. Interesting. Okay, so this is the right. We need another argument then. And I'll just do a copy again. Global global scene. Let's call this buffer. And this one can be data. Global scene data. So that's the actual data. Do pass by copy for now, just for laziness. We'll come back to that. Oh, no. There we go. So scene data, it's a reference, because it's a copy now, and also this is now using a buffer instead. Cool. Seems like I'm getting things together now. Yeah, we need to, I'll remove this as well. I'll make everything a view X projection in the shaders. So we don't have two, which is kind of grown organically. Okay, so as far as I can tell, we're pretty much done. We just need to delete everything called Skybox now. So this, 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 get rid of this, and this. Include shader data. Oh, graphics / shader data. Okay, so anything with the word skybox needs to be wiped. Oh, so nice to get rid of that function. Oh, hate it. I've been hating it for ages. Okay, delete. Very nice. Oh, and this code as well. Holy. Go away. So, yep. And then the drawing code. All this. And you. This. Whoops. Let's go and... Oh, I haven't included it yet. Let's put this with graphics so it's in the right place. And then include... Skybox. Hello, Mado. How you doing, dude? Just cleaning up my code so it's actually readable. Who would have thought putting everything in main for this long was a good idea? A bad idea. Alright. Joke. Joke, joke, joke. Hope you're having a great day, whatever you're up to. And set up. I will put Skybox, Intit, Skybox even, GPU. Exhausted, I'm adding a camera finally. Oh, nice. Well, I hope you get, hope your exhaustion doesn't hold you back. And you're able to crush it, my guy. Okay, so we want to draw here, right at the ends. Draw skybox. There we go. So this needs GPU, GPU commands. This needs the global. What is it called?
the reference. What is this? Alright, we'll come back to that. Okay, so I use SPLB cross to automate pipeline reflection. It handles descriptor bindings, pipeline layout generation, and push constants offsets for graph transient resources in set 2. For set 1 and 0, I use deterministic approach, treating them as fixed global bindless set layouts. Right. It's really cool. I think the thing that JTAG would probably say is, do you need pipeline reflection? Can you make it all bindless somehow? And work out the push constant offsets differently? Like, that's what I started to ask those questions, at least. And I decided not to implement it in this engine. Oh, I could just... I should have just done that. Oh, it's a bloody pointer, that's what's going on. I'm trying to push through, however, I'm glad I'm at this stage. It's been years of just wild imagination and thoughts without actually doing anything. Yeah, I'm glad you got your act together in whatever way. And you're able to just make stuff now. It's all good. So I need C data. When I create this buffer, where is it? Oh, this is it, right. Right, this thing, okay. That's what I need. And then the push constants. So hopefully the copy doesn't break everything. We'll see. It's possible that the copy just, it doesn't like it. Global scene data. Okay, so this is not what I want to call this. This is a terrible name. Global scene buffer. Oh, music is very loud. Oh, I didn't realize. My bad. Thank you for letting me know. Oh yes, it is very loud. There you go. Sorry about that, guys. I didn't realize it was that loud. Let's make this full screen again. Oh wait, now I've gone too big. Okay. Let's just see how I broke everything, and then I'm going to go to the loo. Cool. It compiles at least. Alright, let's just let it rip, see what happens. Vulkan error? Nope. And we still get the textures. Okay, the refactor went well. Cool. And shutdown's fine. Alright, fantastic. So now we have, at the very least, our skybox stuff in one place. Which is fantastic.
And your free floating functions. I'll throw this on the namespace just as it's easier. We don't want to access any of this outside the translation unit. Outside the CBP file. Yeah, let me know if the music's good, by the way. Volume-wise. Yeah, I'll turn it down just again. Alright, so if I build that, nothing should have changed. Okay, right, let's try and figure out how to make this better. Right, that isn't ideal what I've done. Now my first question is, do I need this? I'm kind of confused about this idea. This might be where the view projection is set, so this might just break everything. Just fly around a bit. Okay, so let's just see what this was uploading. So this was the uniform data, because we just don't change any of it. Do we even use any of this data? Yeah, here it is. And if I go into the shader and go, alright, chill. We have view. Okay, so scene data project, and then just view. Where's this scene data come from? Oh, okay. What? What? Oh, I see, okay. Right. I was wondering what that was then. And then it's just project. Current view. Okay, so we're doing something we don't need to do here. As far as I can tell. Position 1. Let's just call this position. Nope. This was like me debugging and I kind of didn't clean up after myself. So it's kind of hard to read. So we have a scene project. And yeah, we do. I think it's just the fact that this works is, I think, is a mistake. I think we do need to do this because we need to be uploading this data for our given pipeline. So that should be able to run. Yeah. Very cool. Boom. Okay, so there is more stuff to clean up. There is always more, but still we are getting better. Right. So again, this class is like super overloaded still. But I'm going to come back to this in a minute. Once I've been... Just need to go for P. Alright. See you in a minute, guys.
I'm back. Back at it again. Alright. Right, so what do we need to do next? So we could break up this scene, the main scene, and the debug renderer. Okay, so the next thing I want to do is actually get rid of view projection in this struct. Because I think everything should be multiplying its view and projection on the GPU, because that's going to be correct for its for the time that it's actually being rendered. Which right now that is not the case. So the goal here is to set a view projection just being multiplied. It's going to be quite simple change. We're just going to go view X projection. Or project. Alright. In our vertex shaded. Oh, yeah, we haven't done anything here. This is. Alright. So, yes, I'm going to keep everything kind of up to date. Even though we don't use those 2D shaders at all. Same deal here. And then we go into here, delete this. And yep, get rid of that. And we're done, I think, with that. That should just be exactly the same without any issues. Oh, nope. He died on a function call, it looks like. What was the issue? Out of bounds read. Oh, okay. No, I didn't update this. And let's just make sure everything. Oh, there's way more. I didn't realize. I thought I hadn't put them in the fragment shader. No, I'm just going to kind of let things break if I've not included them. Alright. So let's do that again. Nope, it all compiled. And let's just see. Oh, I'm in release. I should be out of release for this. Yeah. And that means I think I've committed code that removes the error checking, which is unfortunate. Oh no, okay. I was just compiling in release. Okay. No errors? Okay, so no, everything's fine. Skybox is fine, which is strange. Okay, so Hmm. So view, project, view, project. Why? It's like, it feels like view is applied twice, you know, like a view projection is applied twice or something. We don't, apparently we don't have a buffer device. Let's just check my, yeah, I've got them on. Hmm. Hmm. Yeah, I think we don't use this as well. Hang on. No, if we do, we shouldn't. Yeah. I'll get rid of this eventually, because this function is doing too much. Yeah, what is going wrong? So it's in my shaders where everything's not working correctly. Ignore all the red underscores. That just means it just can't understand. Is it the order? It's view project, right? Multiplied. It's not project view. This might be a render doc situation. Let's see the RAM usage just go real quick. What to do? Alright, we come into an issue. What I'm going to do is commit all my code that I've done up to just before this change. And I'm just going to bring it back again. Because then I can be like, alright, we're at a baseline now. That kind of works. Yeah, so we just need this. And we're just going to investigate like why that's happening. And yep, and fragment shader. Okay, I don't know what's changing there, but I'm gonna leave it. And then we're going to go into our game guy and kind of put that back. In our shader data. Alright. And that is in debug. Oh yeah. Cool. Next is to make sure this runs the way it's supposed to without any silliness. All right, cool. So I'll push this up because this is like some refactoring done. Some of the refactoring work has been done. All right. So, the question is, why is it breaking down? Right, I'm just gonna pick some music myself. Because the music's getting... let's see. Let's pick something else. I've been listening to players for like 3 days, so... Why is my browser going so slow? Have I run out of RAM? No. CPU's at 26. Why is everything so slow? Anyway, yeah, if you just bear with me for a moment. What am I looking for? Is just a bunch of... Trying to find what it's called so I can just get a playlist of it. Okay. Need to scroll down a bit further. That's it. Wagwan Midman Midnight Maximum, right? Wagwan Midnight Lost. Just feel like putting let's go with 4. All right. All right, cool. Let's restart. Yeah, it started. Okay, so when hang on, what I'm gonna check is, I bet it's the padding. This is always the case. So I'm gonna put a Vec 3 in the middle of this. It doesn't do anything. Obviously, I've got to do for literally everything now. I really need an include here as well. I feel like we've got this included all over the place. But anyway. Okay, it's not in there. Not in there. Okay, so throw this in here. And we shall build. We're going to run. No, okay. Why is that being... Whoa, whoops. That's not what I wanted to do. Alright. So what I'm going to do then is... Why do you work? I'm going to just remove this where I can. And I'm going to put view in. Times this by project. But I'm not going to remove the... Yeah, I'm going to leave this in here. That's actually kind of how we're going to work this out. If I remove it, then we don't actually know if it's the multiplication or the data change, if you know what I'm saying. Alright, so we'll give that a shot and see how that pans out. Okay, so it's nothing to do with the actual interesting. Okay, so let's mess around with why is this not working? Okay, sweet. Why am I'm in the wrong shader? Oh my goodness, I'm a idiot. Of the capital. Dear. If I didn't suck so much at programming, this wouldn't be an issue. Oh well. It is what it is. The only way to get better is... Because here's the thing, right? I'm not talented at this. I know it seems kind of funny to say this. So I need to just work hard. Like, throughout my whole life, I've had to work harder than other people just to get average results. So we've just got to keep grinding, bro, no matter what, you know? Maybe one day I'll be able to make something that's like graphically impressive, but yeah, that should fix that. Yeah, okay. So that's just me making a stupid rudimentary error there. What I was doing is just getting the matrix multiplication backwards. It's projection view, not view projection, which, you know, I should know that, but whatever. Now we can at least simplify the code a little bit, because this is the next refactor job. Alright, cool. So now we've removed that. Oh, hang on. That might not work. That might be a buffer overflow thingy. We need to get rid of this and then go to game and remove this. Alright, cool. Next. And that is because we've an overflow for some reason. I thought we didn't have an overflow. Maybe I didn't delete everything from all the tech, so remove that. Remove that. No, we didn't remove that. Okay, so yeah, we missed one. And let's just keep going anyway. Let's go through them again. What I need, I think, at some point in the future is to have a like a global include for this type of thing, because this is going to be pretty much everywhere, but it's not. Yeah, what am I using for a compiler here? I need the I think I still need the. Does GLSL validator still have the ability to have hash includes? I'll have a check in a minute. Because we can simplify our shaders down with a little more indirection, but as you can see, the problem is with what we're doing is we're kind of having I don't think this is valid, but whatever. What do I want to do? I think we've got more pressing issues actually than just shader code at the moment. The next thing I need to figure out is, yes, there's still too much stuff going on in these files. Yeah, these are more important to clean up, I think, than what we've just done, than shaders. Okay. But I've got to figure out what I want to move and where, and if it makes sense to yet. And all that. Excuse me. What do I want to do? Sorry, I'm just trying to think. What I'm looking at here is just like what needs to be moved, what doesn't need to be moved. So just trying to think. So we have our command buffer thing. Yeah. Hi, JTAG. Hopefully you had a good breakfast. Now, I could put the debug renderer, separate the debug renderer from the main renderer. Because I still feel there's a lot of setup code in here that I just don't need to worry about. Yeah, I think that's what I might end up doing. Yeah, I'm just kind of curious. I'm gonna try something real quick. Yeah. Yeah, okay. Oh, nice. Hell yeah, dude. So what I'm gonna do is I don't know if it's like too much faff to do this in the future, but I think it's gonna be easier to read for other people. I think if I kind of abstract this out into its own, this, like every time we create a new pipeline object, we have its own like its own file, like file for pipeline object. I don't know what games should do relative to everything else. Let me think. I'm kind of debating in my mind if I should start studying now as well. So the thing we were discussing earlier about, you know, I don't know enough graphics theory because I've never actually done the what everyone else has done. I haven't paid my dues if that's the case. When it comes to what other people have coded, like most people go through and they, I don't know, render one model, then they render multiple models, then they render shadows, then they render lights, then shadows, then different types of lights. Then they get more advanced with the materials, then they move into more advanced lighting. Like what I've done is gone, all right, yeah, skip all that, and let's just learn about meshlets, and you know, indirect draw calls and stuff like that. Which obviously you can do that way around, but because of that, I haven't gone through I haven't paid my dues when it comes to graphics theory. Maybe skip this song. Just too much talking. So it does seem to make sense to do some kind of practice where we just kind of make some kind of thing.
and just make a second renderer that's like just a renderer, not a game engine. You're just trying to render something as pretty as possible. Well, no, that's a lot. That's not what I mean. Basically go through the basics and slowly make something pretty. Maybe you don't even have a camera, you know, that kind of stuff like that. That basic. It's like the click everyone does. Makes a Minecraft clone. You learn a fair bit. It's fairly cliche. Everyone does it, but make a Minecraft clone. You learn how to make. Yeah. So I've made you know, no, it's good. It's good because it's like, I don't know what air quotes is correct, if you know what I'm saying, when it comes to learning. So, but I have not done that, and yeah, what we could do for the rest of the time at least, because at this point, no, not that. Sorry. I've simplified stuff enough in my code base, I think, to what I could do is, I'm trying to think. We could like leave the rendering alone and just kind of work on gameplay on this, and then like do a renderer in another project. Like it's just a renderer. Kind of separate them out. Because there's a big problem with game engines anyway. Well, a big problem I've seen. If your game, when it comes to like getting other people to play a game, this is the problem, right? If your game doesn't look pretty, no one's gonna play it. I mean, people, like, maybe your friends will and stuff, but if it looks jank, no one wants to play it. And so if my renderer is like not very good, if my rendering ability is not very good, then immediately no one's gonna play the game anyway, even if it has like cool mechanics. Because, you know, just visually speaking, that's what. So it is important that I do have, at some level, a pretty interface. So let's just look at my skybox setup again. This is doing a bit more than just setting up graphics pipelines and stuff. It has functions, it loads files differently. So I'm kind of fine having this in its own file. But for the game code, I don't know what should be in here. Let me think. I think both needs to be good enough. Pretty graphics will be fun for the first 20 seconds with a boring game loop. But a fun game loop will be infinitely more fun than mid graphics. Yeah, I can see, yeah, both. Yeah, you need both, but people, I don't think, we'll see anyway. No one will play the game if it doesn't look good. Effectively, I don't want to end up in a situation where I make a really cool game or whatever. You know, let's just say like people who play it think it's cool, not just me and my mum. But it looks like an asset flip, like a Unity asset flip kind of thing from like 2013, 14. You know, at a glance.
That's true. Yeah, I mean, a unique style's fine. It's just, if it ends up looking like a Unity asset flip, then I've fallen into the uncanny valley of not good enough graphics, I think. No, as long as you make your own models, it won't look like a flip. Or get someone else to do it. Oh, dude. Okay, so what do I want to do this? I feel like the initialization code is a bit overloaded still. What I might even do is take some of this out of here. The reason I'm saying that is just, like we have two pipelines get created here with two shaders. We also build the scene and we initialize the physics. It just seems like the initialization of this is just kind of... I'm just going to end up... So if I had another shader set up, let's just think about it like this. I just want to make sure I'm happy with this like refactor. Let's see if I can do it any other way but better. Device creations, we have linear, okay. Sorry I'm being a bit quiet, I'm just trying to think like how do I want to organize this? Because at this moment in time, this is what main looks like, I guess. But when you go into this file, it's basically the same deal again. Just a big load of stuff all at one go. If I'm trying to refactor this in a way it's like nice. What's the general pattern that I want to follow? So I was thinking of, for every graphics pipeline that we have that has its own shader and its own draw routine and stuff like that, we have its own file, but that's going to be very like, we're just gonna have tons of files then. But is that good? It made sense for Skybox because Skybox is more than just a graphics pipeline. Although this isn't great either. Okay, so let's just say we do that. How would we this is why I love Vulkan 1.4 with the extensions, man. No more awkward pipeline or anything like that. No descriptor set layouts. Damn. Yeah, it's kind of like I don't think Linux with NVIDIA drivers doesn't really... I'm trying to be safe with it, so I'm trying to stick with 1.3. Because NVIDIA drivers aren't very good on Linux yet. Okay, so
If we have like a device creation class or something, because I don't want to lock myself into just doing something like the obvious thing, and then that's just being like terrible. Yeah, pipeline creation. I should not call this like this anymore. Scene, main creation. Let's at least, yeah, let's at least rename these. Make sure there's nothing left that's like that. Yeah, so Q pipeline, noob. How much does Linux matter right now? Yeah, it's a good point. What is this for? Oh, okay. Sorry, I'm just gonna dig into this for a minute. I do want to use Linux. Oh, okay, so. It's not as important, to be honest. That's why I haven't been debugging on it as much. I think getting this engine like not to be crap is like the most important goal, regardless of the operating system. But I think, yeah, how long's 1.4 been out? I don't think it's that important which version we're on, to be honest. Yeah, this is going to be tricky to split up, actually, because the buffers are actually created with the data that we actually got from here, and then these are kind of tied back to this stuff. Which is kind of... yeah, let me just kind of attack this for a minute. So the buffer creation, what is in this thing? Oh yeah, this is the thing I was trying to combine earlier. Yeah, instead of having like model data and like two of these buffers, I think it might make sense to combine them. Yeah, I'm gonna do that. This is the next thing. Yeah, I've been thinking about this for a while, actually. This is like they're basically identical. And if I can get away with just having like one of these, so this, for example, like a superset of both, just having entity data, right, that's used for both types. And maybe I can like reduce the amount of code that we end up dealing with. So I'm going to try that. No, we need that. Because it's almost using exactly the same way everywhere. It's just like one has a extra piece of data in. Yeah. Okay, so now... Do we want to re-access this buffer? Not really. I'm going to get rid of this, I believe. Do that instead. Get rid of this. Entity data. This. Destroy this. And no, we gotta figure out how to, yeah. This just simplifies everything if I can get rid of one buffer. And when I'm in my vertex, shit, so we need model position for both this time, but this time we're going to simplify them down by going against the core shader and doing this instead, right? Now we're just not going to use model. That's currently here. Now hopefully that just kind of solves itself. I mean, we'll see, but yeah, I'm glad I took my time there. And also utils. Let's just see. I might have like split things up unnecessarily. So this is for entity data. It's more like shader data, but it is used in arrays, so oh, this is not going to compile because we have two different shaders things. Yeah, current last index, right? So in this case, we're just going to have a position and a model. We don't end up using it, that's fine. I think that's the issue there. We kind of thought like they had to use everything. And if it isn't used, then I guess I'll just initialize it to initialize the data to something basic. Model equals GLMs map for identity. Yes, this is temporary. We delete this. What else are we missing? Oh, yes, this needs to not now be entity data. This doesn't exist. Sorry, debug entity data. Now this gets updated in the same way. Cool. Yeah, get rid of one thing, the better. Less arrays, less memory usage. Everything's simpler. Alright, let's go into Right. As far as I can tell, that's going to help us out. Assuming that the shaders accept what we've decided to do here. I'm just going to make sure again that we have model position. This is for... Why is this like this? Oh, okay, right. Yeah, kind of annoying, but whatever. Alright, let's just compile and just see what happens. Nice. So as far as I can tell, although the dogs fell out of the... Yeah, that seems to have worked. We've got one less buffer. And it all gets freed. Yeah, it's a bit of wasted memory on the GPU when we're not using that model data, but... Yeah, that model data is only there for the debug models, so maybe I should say debug model. The reason that's because we might have, for actual models, we have submodels. So the model in the other struct is like a submodel. So, yeah. It's not that important, but I will go into the shaders and rename them all. Ah, right. We don't use the shader, that's why nothing, like everything kind of worked. Oh, what am I doing? Literally. Okay, so... Okay... And I think we're good. This is going to be a nice little refactor / simplification. Okay. That didn't work because... Okay, debug renderer. It's trying to use something called model, and it's not called that anymore. No. Oops. Yeah, that's fine. I'll just fix it up afterwards. Fantastic. Get rid of the semicolon. Nope. That's what I'm interested in. Thank you. And anything else? Oh, look at that. We saved some RAM. We've saved 200 megs of RAM. Well, maybe 100. Well, we've saved some type of RAM anyway. Cool. Alright, so that's helped us out a ton, so we can actually look at... yeah, this is game specific, I guess. Even though this is going to touch the shader. Whatever. Next thing to do... no, we did it. Okay, we deleted that. Let me just check something real quick.
Sorry, just give me a minute. It's going on a bit longer than expected. Cool. Yeah, just sorting something out there. Okay, cool. So we simplified that. We still have one material, which is kind of making us not fully bindless. But the problem is we would need... At some point, we're going to have to bind something anyway. Maybe this is the advantage of using descriptor heaps instead of buffers with buffer device address accesses. I don't actually know the benefit of buffer heaps. It's just the memory layouts just seem to be way more complicated. But with the problem with the way I access buffers with these pointers or whatever, eventually my push constant is going to run out of space because there isn't that much space in a push constant. I think at the very least we're guaranteed 128. It could be 256 on newer versions of Vulkan, like 1.4. I can't remember. Okay, so entity management might be the next thing that we work on. I'm not gonna lie, I'm getting very hungry. The benefit is that descriptors are way easier to manage, and use it totally gets rid of descriptor set layouts. No binding, no sets. You just call vk bind descriptor heap to bind the heap. Oh, I see, because there's like a table, so it's kind of like... So the way I'm accessing things with buffer device address, I guess, would be like what the heap table is doing. But like because of that extra layer of indirection with the table in the GPU RAM. To register into heap, you call the specific VK functions. To register into the heap, you use VK functions and takes all the... Nice. I see. Register into the heap, specify takes all the... so it helps with bindless textures then, because I know you have to do that completely different. Well, buffer device addresses have nothing to do with descriptor heaps or buffers. Buffer device addresses is only used for accessing any buffer using a GPU access. Right, no. Sorry, maybe I've conflated two ideas here. There's this article that I read called "Descriptors Are Hard," and it talks about why Vulkan 0.1 went with hardware. Sorry, it went with let me think. it went with fixed, like it went with its original descriptor set layout kind of ideas, right? And that's because back then GPUs still had fixed hardware slots for things like descriptors and sorry, for buffers. So it had to kind of compromise and do this kind of like thing that no one really liked, but was kind of like it couldn't do bindless when it originally came out. And now obviously we're in the future now where, you know, fixed hardware has been a thing in the past for like probably a decade now, because Vulkan obviously had to, you know, work with things in not just when it came out forward, but things, you know, in the past. That is meant for driver developers. A lot has changed. Yeah, so when I'm talking about like heaps and heaps and buffers, I'm actually talking about like how the memory is accessed more than what the Vulkan spec is doing. What is Vulkan doing specifically, you know? So I imagine that the driver is doing some kind of extra layer of indirection to access this heap table that is on the GPU versus the direct access and or buffer access, which has like two different ways of doing things. Okay, we've got like a random. What the hell's that? Got hypnotized in the middle of that playlist. Not really. The heap addresses are bound by putting their addresses into GPU registers. The heap addresses are bound. Oh, hang on. My computer's dying. Yeah, that's true. Yeah, NVIDIA doesn't have... it's more like Qualcomm and stuff like that. I see. Well, anyway, regardless, we don't need to worry about it as much, I guess, like you said. Alright, so what do I want to do then? Alright, let's push up this code, because we kind of half did the simplified the buffers and reduced and reducing memory consumption. And simplified buffers, reducing memory consumption, and refactored tons of stuff. Nice. Okay. So this deletion code is horrendous.
let's see if we can reduce some of that memory overhead by just making sure that we're not allocating things unnecessarily. I'm kind of curious, is the movement smoother now? Because that was a big issue I had earlier. No, it's not. Okay, it still does that. I'd obviously move keyboards, mouses from the game, but it's kind of moves around like crazy. Sorry, I'm just looking through, just trying to see if there's something else I can, like an easy W on refactoring. So I don't like this utils guy with this being here. But if I get rid of that, then because that is technically a buffer, and that should be in the shaded data. Yeah, I'm gonna try and move this out because it's kind of confusing. I know it's gonna make things a little harder to navigate, but it should, because it's shaded data itself. I kind of want all my code together. If I go to my scene code, we should see something. Oh. See. What? How you found it? Whatever. I'll just throw this in as well. Shade. Oh, what am I doing? That's the other thing I want to get rid of. So, with I want to get rid of this function. So it's used in one more place, so we can probably get rid of it if we can. That would be great. So we are going from a undefined to depth optimal. Okay, that should be straightforward. So let's copy the code out, I guess. Oh no, this is version 1. Let's do version 2. There we go. So for our pipeline barrier transition, we just need to kind of do the same, but for color, I think. For depth, sorry. This is a texture, yeah. Yeah, because Ratchet really got onto me and said, you know, you don't want to have these big, like, functions that kind of just transition everything. It's not a good idea, so yeah, that's pretty much what we need to do instead. And yeah, I don't know if you know, by the way, but your clear color is 1 frame behind. Is it? That would be in my main. Alright, I'll fix that in a minute. Yeah, thank you for pointing that out. It's not. I just don't want to
go away from this and then like completely, you know, forget what I'm doing and then this breaks or something. Let's format. What are you doing here? So that, yeah, okay. So VK format was the. Format. Which one of these is the format? Give me a minute. Yeah, I'm just gonna get inspiration from my texturing code. So the layer, I believe the layer count is going to be 1. Aspect mask, obviously it's going to be depth. Which I believe is probably what this is, right? No. But yeah, let's get the depth version. And it's going to be 1. Now, if I go in here and see the formats, then I guess I can just see what do you use for and where. Oh, yeah, we need to also make it stencil, I think. Alright, cool. Let's have a look at this. Oh, okay, so it's just some kind of like checker. We can probably throw this in. I don't think that's like particularly. Yeah, we'll do this. This is fine. I think it's that complicated. If it has stencil, then we also make it have stencil. Oh, got to add that twice. And it's just this fella. Tells us what the format is. Cool. And then we do a pipeline transition. And I believe this is the bottom of this. Yeah. Alright. So if we comment out this, oh, player setting entity data. Okay, yeah, so shade graphics shader data. Oops. Alright, and that's fine now. What? Right, I'm just going to assume that function's kind of balked because of that one error. And then we'll see. And then we'll have a look at our color or whatever. Assuming that it, well, we'll delete our code first. In here. And we're fully on synchronization 2, I believe. But we'll see if we get a Vulkan error. Nice, we did not. Alright, cool. So this guy is gonna die now. Wherever it is. Cool. I'm just going to compile that just in case it's used anywhere else. Right, cool. And eventually we'll get rid of this as well, but one step at a time. Okay, so if you don't know, by the way, your clear color is one frame behind. You don't actually need a separate clear color from the from begin rendering. Let's have a look. So the begin rendering will be in here. You don't actually need a separate clear color from begin rendering. What do I clear color? VK. Whoops. VK clear color. Not that. What am I clearing? There must be something. Yeah, okay. Okay, so you're telling me that these automatically clear. Let's read that in the docs. So I don't need to clear twice, effectively. So these functions are redundant. No, these are setting the values. Where's the actual clearing? Your clear values read, but you're setting only after calling. Ah, okay. But you need to store the clear colors. Right, okay, that makes sense. Okay. Yeah, I see what you're saying. I get it. I think, anyway. Yep. You can tell me if this is wrong in a minute. No. Jeez. So there's the begin rendering. And this needs to be done here because it sets the colors and then we begin rendering. No complaints, and there we go. So yeah, this is probably a bad name because all these are doing is setting the color. I see what you're saying. We could just pass them in here instead of storing them. And that would save, I guess, a bit of RAM. Oh no, I don't know what it would save. But it yeah, okay, let's yeah, I have no qualms with that idea. That we just do kind of like, if you want to set the colors, because it's kind of setting them manually anyway, there's not really anything that sets the clear color. Kind of like this, and let's just absolutely get this right. like this. Whoops. Yeah, I'm gonna agree with you. It's just this can simplify everything a little bit. Nothing crazy. And also, yeah, like you said, there we go. And for a nice blue, I'm gonna kind of copy this out. Kind of gonna say like this. If you want blue, looks like a blue. If we need to do a clear color for that particular reason. Yeah, I'm fine with completely just shoving it in here. There's no reason. I was setting the values anyway, you know. I was just hard coding the values in a different way, so. Okay. This is the other thing I want to get rid of eventually. This is like my worst thing that I brought over from the Mastering Graphics Programming book. I mean, do we even run this code? Update descriptor sets, so I know set descriptor sets, yeah. It's it's just it's very convoluted because it's trying to do stuff differently for bindless, and it's okay. What I might try and do then is what I might do is delete a bunch of stuff like the profiler and stuff in this engine. And stuff like that. Like, trying to simplify this a lot more than where its current state is. I mean, it's already been simplified, believe it or not. This is like a much simpler version of what I was working with originally. But it might be a good idea to kind of like try and use this thing to like go through and build different scenes, if that makes sense. Like, I know you said it would be a good idea to like kind of start from scratch and just do OpenGL or whatever, but we can probably hit two birds with one stone if I just kind of get better at Vulkan plus render, like do the basics. Yeah. That's what we're gonna do. I need to go and eat. So I've got my lunch ready though. Yeah, so what we're gonna do, I think, after lunch, if I don't know if I'm gonna keep going, but I think we should be, yeah. If I'm gonna be a graphics programmer that's worth its weight, that's worth their weight, I need to be able to do the basics, even if I don't even use them. Yeah, because right now, the stuff I'm missing is just not acceptable, really. At this level, anyway. So what I'm gonna get, yeah. So what I'm gonna do is I might make a new branch in GitHub, in Git, and kind of eviscerate this thing and just kind of simplify it back down to basics and kind of build it back up. I'm gonna keep some of the stuff, but for example, I might even get rid of like the debug renderer and just concentrate on building like a good renderer, which just does interesting things. Something like that anyway. Okay, I what I'm gonna do, right? Pause that for a minute. Do we get up a video or? Yeah, because I want to be able to do this eventually. And I just need to get... Oh, I think I did... sorry, you said something on GitHub. Yeah, I know what you mean there. Sorry, JTAG. But I'm totally fine hard coding the values because I won't change the clear values ever. The clear color values. I especially won't clear the depth. I would change the depth. No. I think we have. I don't know if you saw me do it. I don't know if you stepped away from the computer, but yeah, I have removed those functions, and we are. We're just hard coding these values in, kind of like this, because that's what I was doing anyway with the functions, with the helper functions. Like, if this is where the clear values happen anyway, like, just stick them here as straight numbers. It's not like there's going to be an up, like, oh, I need to change the clear color values here. Yeah. Yeah, sorry, I didn't understand what you meant. I just thought, you know what, if we're gonna send them in, might as well just hard code them in, rather than having helper functions even at all. Because we have dynamic. Because this was done with render passes originally, this code. So it was different how you did this. You did set the values, and then you did like set the begin render pass. So it's similar setup, but it was different. You don't need to store the clear colors on the buffer. They aren't required for anything else. Are you talking about this, the store? You don't need to store the clear colors on the buffer. They aren't required for anything else at all. What buffer? Sorry, I don't quite know. Okay. So I'm debating whether to end early or should we load up a vid and then kind of I'll study on stream. I'm kind of like, I need to figure out what I want to do, to be honest. Okay, so
Yeah, I need to figure out exactly what I need to do, to be honest. Like, do I want to make a game? Do I want to just get really good at graphics? I don't know. A bit conflicted at the moment. So, yeah. Yeah, so I'm probably going to call it here then, regrettably. I kind of don't want to, but yeah, I feel like I need to do something else for a minute. I will copy in the Discord. There you go. And yeah, I'm going to eat some lunch, and then we're going to get back into... I'm going to probably come up with a different way to practice something, okay? All right. See you guys.